So to kick things off, I'll pass over to you, Robert, to share with us some insights of managing this trial.
Okay. Afternoon, everyone. Just to welcome you all to Orari Gorge. Just a little bit about the property. So obviously South Canterbury, just near Geraldine in the South Canterbury foothills. We start at about 200 metres and go up to just over 1,000 metres. We're just over 4,000 hectares, roughly 10% flat, 15% rolling, and 75% genuine hill country, tussock country. So we're running about 50% sheep, 25% cattle, and 25% deer. We do get rain. That was just leading up to AI a couple of years ago, just ideal timing. So 1,200 mils a year, generally summer safe, supposed to be winter dry-ish. That certainly hasn't been the case the last winter or two. The sheep are sort of Romney-based, about just under 9,000 ewes, about 700 Herefords are all recorded, and we're up to 2,000 hinds now, fawning, been slowly increasing from 1,500 about 5 years ago. Okay, so a bit about the trial. First of all, just want to declare conflict of interest. Yes, I do have a sheep stud. It's not normal for a beef and lamb progeny trial to be run on a sheep stud, but I was part of the group that wanted this to happen. There was a couple of reasons I wanted to host it. The main reason was, as a stud breeder that has been focusing on low input traits, it was really hard to find outside sires from studs that were also recording those same traits. So worm fact started in about 1991, 92. 20 years later, 25 years later, there was only 30 breeders measuring worm resistance. And you split that between breeds, there's only a handful of each breed measuring it. So I was really restricted where I could confidently go and buy a low input ram with high production. And time again, I'd take a punt on a ram, and he might have some good weaning weight, so the genetics were there. But as I extended the drench interval, they'd be drenched at weaning. So 6-7 weeks later, I'd get them back in, and the progeny from the outside sire had hit a brick wall. So slightly a different climate, and partly they weren't putting any pressure on the worms. So I wanted to see rams used in my environment that could prove themselves, and then I could potentially go to that stud and look at buying a ram from them. The other reason I put my hand up to host it was because I was worried no one else was going to. We'd had about 2 years trying to get this thing off the ground. We finally got the funding. We suddenly, well, where's it going to be? There was a rumour it might be Telford. A week later, there was the announcement from Taratahi that they'd gone under. So decided Telford might not be a safe bet in the long run. So Beef and Lamb made the decision to let me host it. These are the other reasons why we wanted to run the trial. Is drench resistance, as we know, is a growing problem. Rumours of up to 60% of North Island farms having resistance to triples, less in the South Island, but still growing rapidly. We're struggling to get good workers. I mean, shepherds might want to go mustering on hills, but they don't want to be dagging and drenching lambs all week. And also the marketplace wants less chemicals in the food. So there's a multiple reasons why we needed to host it. And the other one as a stud breeder is the linkage, because if I've got my stud or even a group of studs that are measuring the traits, and a group in Southland are measuring their traits, and a group in Northland are measuring the same traits, unless there's some trial or progeny test going on to link those groups, you can't compare the genetics or breeding values from one flock to another flock. And so that's the origins of the central progeny test that started back in 2000. It was nothing to do with finding the best ram. It was to try and link the rams, link the studs, and especially across breeds. because no Romney guy is going to try and Coopworth just to get linkage so someone else can compare the genetics. So that's where beef and lamb come in and do the progeny test. But the problem with the progeny test, to a certain extent, they've got to carry out best practice and they can't put them under too much pressure. So it's hard for them to really measure the worm resistance and the Dags and things like that really under pressure. And worm resistance and Dags might be okay, or the rams might rank one way for the first 5 weeks. But when you really stretch it out and really put them under pressure, a ram you thought was okay suddenly isn't okay. So we had to have a trial. There was a few of us stud breeders that thought the same, that we needed a progeny test that was actually putting the progeny under a challenge and measuring all those health traits, low input traits, still measuring all the production traits and getting that linkage across breeds and across breeding groups and things. So what are we measuring? Pretty much everything. These are all the studs. So 17 rams each year, roughly, across all breeds from all over the country. It's not that cheap donating a ram into a progeny test. You've actually got to pay for all the semen collection. You've got to actually pay to have him enter the trial. So there's a bit of commitment from these studs. So these guys need acknowledging as well. And so what are we managing? Well, pretty much everything apart from FE. So we start off with obviously AI, pregnancy scanning, DNAing and tailing. I'm not going to say docking, it's tailing. So we've got a survival from the preg scan result. Weaning weight, we're DAG scoring at weaning. We've then obviously got growth. So the lambs were weighed pretty much every 4 to 6 weeks, all through the autumn. The first year they were taken all the way, when I talk about putting them under pressure, they were taken all the way from weaning in December, they got a drench, and they went all the way through to the middle of May without a second drench. And that's in a summer safe environment that's ideal for worms. Worm counts were 1,500 by February. We still didn't drench them. We managed them through it, put them on the clover for a little bit. We found the clover to be a very valuable tool. But as some people say, yeah, but that's not genetics, is it? Well, no, it's not genetics, but it's part of the toolbox. And a week on clover, they look like different sheep. Took them back off the clover, back onto the grass where they were before with the high worm counts. Another 3 months. And the lambs, each lamb individually worm counted in February and individually worm counted again in May. So that's the resistance. The egg count is the resistance to worms. The resilience is a bit more complicated, but that's more the growth rate relative to a control mob. You can't just compare this year's growth rates with last year's growth rates because the season's different. So each year there was a control mob of about 20 or 30 lambs that was drenched every time the group was weighed. So we were comparing each sire line with the control mob each time. And it was quite interesting. Yeah, they didn't keep up with the control mob, especially when you start getting 5 months out and they've been drenched 5 times in between. But some of them weren't far behind. So again, it's a learning curve of what is possible. How far can you push out those drench intervals? We got the eye muscle scanning. We've also got carcass data from the boys that were killed. So way back at tailing, we left the tails on the boys and tailed the girls. So we were measuring tail length. We're measuring the length of bare skin under the tail. Everything we could think of like that. The boys were muscle scanned with ultrasound before they went to the slaughter. The ewe lambs, we didn't mate them, but we did put them to a teaser with harnesses, so we had them marked for estrus. And then those ewe lambs have gone through. They've had wool weights measured at 15 months, individually fleece weighed. They've had methane measured. About 12 ewe lambs from each sire went to Invame. They were measured for residual feed intake. So every mouthful was measured how much they were eating. Their growth rates were measured over the same interval, and they were measured for methane down there as well as being measured on while they're eating grass up here. They were measured for bareness. So there's been all sorts of breeds, including Wiltshires and things in the trial. So as well as fleece weighing, also measuring bare breech and bare belly wool. Not so much shedding, but bare patches. And then those daughters have gone through and been mated. And we've had 3 two cohorts have now had lambs recorded. And then their progeny will go through all the same measurements again. Okay. So tailing, as you can see, not a bad view, measuring the tail length, so measuring the bare skin and then measuring the tail length as a whole. The residual feed intake was down at Invermay. They have to go into the thing with their EID and it's recorded who's gone in and how much they've eaten. That's all going to be talked about later. The methane trailer came around here and it goes around other studs as well, and it was down at Invermay. The Dags, and to me, this has been one of the biggest sort of eye-openers of this trial, because most of these rams came from studs that were already doing some low input work. And the difference in Dags between sires was phenomenal. Why did we leave the tails on? Well, because the tails make a huge amount of difference. And if in the future we're not allowed a tail, we need to start thinking about it, because we'll see some lambs outside later, but there's a big difference between tails. And when you leave the tails on, so the top graph is the ewe lambs that had been tailed, and that's their DAG score. So you can see the vast majority of them are coming in with a DAG score 0, which is totally clean. 1 is only a tiny bit of DAGs. 2 is still not too bad. The boys, completely different graph. So that's measured on the same time of year, same amount of time off drench. Totally different. And if you can see in the picture here, so that's about March, done at muscle scanning. You've got lambs there that are clearly still a 0. This next slide here, that there is only about 5 weeks after weaning. So the ram on the right, he's clearly a 0. The one in there, he's already a 5. When we killed these boys, some of them were so bad, out of curiosity, we actually weighed the DAG. So we had 42, 43 kilo lambs going to the works. We measured 4 kilos of DAGs off them. And so when you're doing live weight and wanting a killing out percentage, you've got to bear that in mind. And like I say, it's one thing trying to get shepherds to go and muster on hills. That's pretty good fun. Drenching, not so much fun. Dagging those things, definitely not fun. That's annual leave time. They're pulling sickies. They're wanting to know what time smoko is, that sort of stuff. Yes, I mean, that is a huge expense to the industry. It is also the easiest and cheapest trait for any stud breeder to measure. They're weighing them at least once, if not twice, if not every month, depending on the breeder. They're right there. They're standing on the scales. Have a look. 0, 1, 2, push a button, done. It takes you 3 seconds longer per sheep. And all of a sudden, you've got a huge amount of information, and it's really heritable. But I mean, that to me has been the biggest learning of this trial. It's been such hard work dealing with those excess DAGs. And when you see the fellas in the same paddock, that's just straight genetics. Yeah. What else we got? Yeah, so the hog at estrus, so teaser marks, teasers went out with harnesses and sort of split it into 3 periods, I think, sort of 15 days or 12 days. And then, so going back to why I wanted to host the trial and what I think we've achieved out of hosting it, it comes down to this table here. So, so you see the worm effect. So there were 61 flocks in 2018. We're now up to 92. DAGs are 52 up to 99. Body condition scores gone up. All those traits have gone up in the number of studs recorded. If you went back 2 more years past that, back to 2015, 2016, before the trial was even talked about, like worm fat was down at 30 studs. There might have been 40 flocks, but some stud breeders had 3 or 4 studs on their farm. So I mean, you've gone from 30 to 90 in 5 years of stud breeders recording. So to me, yeah, it's not about trying to sell more rams. It's trying to make my sheep better, and I can't make my sheep better if I have to close the flock because no one else is measuring the traits. So I need to use outside sires. We all need outside sires. A lot of commercial guys don't realise just how much stud guys talk to each other, how much we learn off each other, how much we share genetics. interact with each other. So, I mean, none of us can do it on our own. We need each other to drive the whole thing forwards. So the whole industry, not only my stud, my commercial flock that's benefiting from my stud, but every stud and every commercial guy is benefiting from more and more stud guys recording these traits. Because like production is one thing, but cost, as we all know with the inflation at the moment, cost is the real killer. So, and I think that's been the huge success. And the connectedness, the bit underneath. So if you start recording, that's one thing, but you've got to be connected. So you need there's normally you see the Dags score, it's pretty much a 2-year delay between when they record it and when they become connected. So that's sort of, you've got to have progeny shared on the farm and things like that. So that's why there's a bit of delay. But I mean, that's just growing and growing. And then at the bottom, we've got methane coming in as well. So I mean, from those 3 studs in 2018, I'm pretty sure they were probably just research studs. They probably weren't actually commercial studs, but we're now up to 30 studs out there recording methane, and that's only going to grow with the latest government sort of barriers they're putting up against us. They're getting 10% genetic difference between sire lines. We're told we've got to reduce our methane. Well, there's 10% sitting there just in your genetics. So it's going to become an important trait, just like growth and fertility and Dags in the future, potentially. Rightio. So I've kept it a bit shorter than I normally talk for, but I'm really keen to get some questions, get some discussion going, both in the room and online. So if you don't ask questions, I'll just keep talking.
Yeah, hang on, I'll get you a mic.
Yeah, just as Sarah said earlier, just wait for the mic because we might hear, but the people online need to be able to hear.
Where do you buy rams from?
Where do I buy my stud rams from? Well, ideally, the guys that are recording. Yeah. And so, I mean, I've got 2 maternal studs. One's a Romney stud and one's a Romney Texel cross. Like I said right at the beginning, one of the reasons I wanted to host it was try these different rams. No one ram came top at everything, and they never will. There's too many traits. They can't be good at everything. No one breed was good at everything. So having seen rams doing this, I have gone and used 2 rams of different breeds in my stud, because to me, I mean, some of my clients might disagree. They want to be a pure Romney or something else. To me, it's about production. I mean, pretty much every breed in the country is half Romney anyway. So to me, it was trying to find the best genetics. So I've even widened that to, I don't want a licorice all sort composite personally, but if there's a ram out there that's going to make me money, I'm not afraid of going to use them. So I've gone and used different rams. But the thing is now I can buy rams with a bit more confidence than I used to be able to, because they're recorded at home.
Robert, can you ping back to the lambs that you had there with their tails on? Yes, those ones there. One of the things I found very interesting, measuring tail length. If you look at the hock, how far down the lamb's tail goes to the hock, and that there's fairly typical of our standard brace Romney. It's about, I don't know, 2 inches below the hock. With the introduction of Texel and East Frisian and probably Finn, you'll lift that tail to 2 inches above that without much trouble at all, which, you know, makes 4 inches shorter. They also have a bear tail. We've been looking at shedding tail, which is the piece above the tail. We all can do clear patch, but the shedding tail is to be able to get that wool to just naturally drop off that top of that tail. And that stops it hanging down over. You're saying that, you know, opportunities to go forward. There's a chance there of doing that.
Yeah. And when we're measuring the tail length, we also measure the leg as well. Because if you have 2 tails that are both 30 centimeters, but one of the lambs might be twice the size of the other lamb at tailing. So we have had it correlated to leg length as well. And yeah, there's definitely a huge difference. And the Texel does tend to be a bit shorter, but not every Texel. I mean, a lot of breeds around New Zealand over the last 20 years, there's no such thing as a pure breed anymore. And But yeah, I mean, we'll see the lambs outside later on. There's a huge variation in tail length and you say that wool on the tail, because even if you've got a short tail, if it's woolly, it's still going to catch the shit. But the Dags, people talk about the bare skin. You can breed for Dags with wool or without wool. They're sort of slightly independent, not totally independent, but they're slightly independent traits. You've got to
agreed.
Don't just think Texels have got bare bums, they won't grow Dags, because by crikey they can. A lot don't, but a lot do.
Yeah, each trait is separate and different. The clear patch is different.
Yeah.
The shedding tail, I call it shedding tail. But you're right, they're all separate and different genes.
And trying to get that without losing fleece weight is a bit tricky, but that's why we measure everything and try and get the ones that can head in the same right direction in two different traits.
Thanks, Robert. I just commend you guys so much for getting this trial started. I know what you went through to get it off the ground, and looking at the results are just exceptional, and the benefit to us as commercial farmers is huge. My question is, are we calling this too short? Like, is there still far more that you as a breeder can get out of it and the commercial farmer can still benefit from it for going longer? Or do you think we have all you need now to carry on the same momentum? Do you understand that question?
Yeah, and that's certainly a question that we've spoken about a lot the last few months. And yeah, in some ways, no, we'll never have enough information. That this is not going to go away. We need to keep measuring it. But at the end of the day, how much are we going to gain from just keep measuring the same thing? The one thing we're losing is that connectedness by having a place where progeny trial, where crossbreeds can come in, all sorts of breeds, be measured really under pressure. I think that's the biggest loss. Hopefully with the remaining central progeny test, they are doing more of that. They are putting them under a bit more pressure. They're doing more worm counts and stuff. So that is going to come. And at the end of the day, it doesn't matter how much we do this, it's got to get out there. So if beef and lamb, they say that they're not going to fund this, there's still quite a bit of money to spend on this. We've still got a couple of years. We've still got 2 more years of daughters to put through their first lambing and measure fertility and weaning weight. But hopefully any surplus money is going to go into the extension, because we've got to get this message out there. I mean, there's people in the room here, there's people online, but there's a huge part of the industry, both stud breeders as well as commercial. I mean, if a stud breeder isn't recording any of this and he's got a band of loyal clients, why would he start? Because it's bloody hard work. So we need to, the commercial guys are the only ones that will drive a stud breeder in the right direction. I mean, if all his all his commercial clients say, well, are you recording Dags? He says, no. And they start walking away, he'll soon start measuring Dags. If you're a commercial guy out there, ask your stud breeder what he's recording. And if he's not recording, ask why not, and find someone who is. If it's a trait that's important to you, find a stud breeder that's recording it. Doesn't matter what the trait is.
Yeah, Robert, Andrew Bendel, possibly a good segue into my question. I agree with Hamish, commend you on taking this up, and beef and lamb for doing this. I also think, we need another 5 years plus. But I guess the question is what you've learned within your stud operation, how much benefit would it be, given your size of your commercial operation, if you knew which 30% of your commercial ewes to cull because they were the worst performers? Would there be a benefit in knowing that? Because yes, all us as stud breeders are driving the change, but our real opportunity is actually being able to measure and monitor and cull our commercial ewes. Yeah,
and that's always difficult, isn't it? Like, there's a lot of ewes and cows that are culled for the wrong reasons, because we really don't know much about them. Yeah, I mean, I've seen it myself here when I first started sort of playing around with sort of semi-recording commercial cows. You see a weak calf, and or you just follow it around so you get the cow, and so you can cull her. And I remember the first year I did it, wrote the cow's number down. I was just about to drive off, and then this massive great calf went in for a feed, and the little calf was actually just a stray. It was just getting a feed off anyone. So I mean, whether you're doing it like that or whether you're doing it on body condition at weaning, you cull your poorer ewes at weaning. You probably just culled your best mothers. Give them a chance to bounce back. If they're still skinny at mating, then yeah, that's when you need to step in. So here with our commercial ewes, we don't do much different with any of them at weaning. Put them back on the hill, bring them back in to sort them up into mating mobs for mating. And if they're anything lean, then they're allowed a drench. No, none of our ewes get a drench. But if they're skinny, they get a drench. They get a black tag. That's it. They're a terminal ewe. Some of them end up one drench saves them the 3 more years of good production. Some years the next year they're still skinny. They go to the works. But yeah, and how a commercial guy can measure those things is hard. Yeah, whether we're all going to go around the DNA route, but there is sort of commercial DNA tests with heifers and things coming along, but I think it's a fair way off with sheep, and it's not that accurate. But you're right. There's a lot of ewes out there getting culled that shouldn't do, and big fat ewes in the flock that have never made you $1. And you keep them.
Robert, I'll just make a quick comment. Dan Brier here from Beef and Lamb on Hamish's question. So in terms of what we are thinking with this, this project has been really successful, right? We're really pleased with how it's gone. It was a 3-year project which we extended for the extra year with MPI's funding. Their funding has come to an end now, so we've got to make a decision about what we do, right? Jason, who many of you know, and Sarah have run a really quite a in-depth program over the last 8 or 10 months around how we best use our resources to get the best back for our commercial farmers and our breeder farmers. And so that's really driven us to just go down to the 2 progeny test sites and really focus on connectedness and how we help our breeders get connectedness, which was a key part of this in the first place, because that can be done at progeny test sites, but it can also be done not at progeny test sites. So working on that piece, and your other point there about the extension, right? We've got some data here that's allowed us to have enough breeders working on this. Now we need the other end of that. We need the farmer pull to help get more breeders involved in it. So that's how we've decided to, I guess, spread our resources across that.
Yeah, I guess it's, as Robert said, that you've just got 2 years of females that have now got progeny. As we all know, when we've got sire summaries and you're sort of 6-7 years down the track, you suddenly see the true worth of a ram that you've used 7 years ago. It'd be just a shame not to at least follow things through because our genetic engines are our ewes. The rams are just the vehicle to get from A to B. I just see absolute huge benefit in finding more information. We've gone this far to keep the investment going, and that's got to be driven, as you've said, by the commercial farmer.
So I think Robert just mentioned before, but we really are going to follow those ewes through. So the project officially ended with last year's lambs, 21 lambs. We did another mating in 22. Those lambs have just been born now, so we follow those through. They'll go through till we get reproduction on those lambs as 2-year-olds. And as you know, the investment in that will wind down. As that winds down, we're going to up our investment in education, and not just education, but what we're thinking really is breeder group facilitation. So, that's up for grabs. We haven't worked out how we're going to do it yet, but, if low input breeders want a bit of help, we're going to have some resources to help them. But I think really, it's at the point where, as Robert said, there's a bunch of breeders doing this now. We've got it. The gains are going to come from their flocks, not from the progeny test flock per se, other than that connectedness thing, which we'll do through the CPT.
Just got a comment here from Alan to your point, Hamish, around there's more we need to know. He just said there's a drive to more shedding sheep. These sheep can also have Dags, and that's not necessarily widely known amongst farmers. So it's not just all about shedding sheep. I don't think we've got anything else online, but if we've got any more questions in the room.
Why are all the questions about how you fund this thing and what's going on and what's going on in the future? And why aren't there more questions about why you guys haven't started this 20 years ago?
Who wants to answer that? Why didn't we start this 20 years ago? Well, the one thing, when the central progeny test results come out each year, and there used to be a big sort of table of which ram had done well and stuff, all public knowledge, worm resistance was always in there as a trait measured. And so I sort of naively assumed that they were putting them under a bit of pressure and measuring worm resistance. But I later found out that they're not under nearly as much pressure as a stud breeder that's doing resistance properly. So we sort of thought, either didn't think about it, or we thought it was being done to a certain extent. And then, with the funding, these things aren't cheap. And especially when you put in the stuff like the residual feed intake and the methane, that's real next level sort of stuff. It's one thing me running it here and I can weigh them a few times, but just little things like the tags, the DNA, so the beef and lamb people coming to do the measurements that I can't do. They've only got flights and accommodation, stuff like that. It's phenomenal, and it's not wasted money. I've seen sort of some of the bills and stuff. I know something like the amount of money it takes to put in a methane chamber at Invermay or residual feed intake. It's a lot of money, and they've got to recoup that money. They can't just sort of open it up for free. They don't have the funding, just like we don't have the funding. There's always something else you can measure. There's another trait that's going to come along. We weren't measuring methane 20 years ago because we didn't think about it. We weren't measuring drench resistance because we didn't think we had it 20 years ago. Whereas now it's really hitting people in the face. So 50-60% of farmers with combination of triples, they're thinking about what they can do with the farm. It was sheep, can't use sheep, maybe cattle. All of a sudden trees are on the horizon. So it's even more important if we're going to produce food in this country. We've got to do it. And genetics aren't the only answer, but they are a serious part of the toolbox. They're a pretty big hammer in that toolbox. We've learned a huge amount with the clover. I mentioned briefly on that. You can't have your whole farm in clover. You can't graze clover all year round. You can't sort of run cattle on it at certain times of the year safely. The genetics are a big chunk of the answer to sustainable sheep production and any species production. Yeah, Dougal.
Yeah, that's on. Yeah, just one thing you haven't mentioned is flies.
Yeah.
And fly strike.
Yeah, so, because we weren't crutching them and we weren't dagging them, we did dip them. So they were dipped. We did things a bit differently each year as we learned. So the first year we actually crutched the boys and then took them through, and then we shore them in March. And so that when they were crutched at weaning, they were dipped as well. I think they got through. They weren't quite going to make it to shearing, so we did dip them in February, and then they were shorn in March, and then they were good then through to slaughter in in May. The following year, we decided not to crutch them, and as you can see, that ended up being a bit of a mistake because it comes down to the wool. The more wool you got around the tail, the more dags they can catch. We didn't have serious fly breaks, but we were keeping an eye on it. We did dip. But I think, I don't know whether it's years of not trying to drench too much and not trying to dip too much. Potentially the sheep have got a bit of natural resistance to fly. And it's interesting, you go out there and you see a ewe or lamb that's struggling and it's got fly. I think, it's struggling because it's got fly. Whereas I'd beg to differ. I think a lot of them get fly because they're struggling. I don't know if there's some sort of pheromone they put off that the fly can detect, but I mean, I've gone out there when I'm putting my lambs under pressure for worm resistance, and I'm monitoring them almost every day. And I can go into a paddock and say, right, I've got to drench these. So that means I've got to worm count them now. I look around, make sure they're all okay. No animal welfare issues, no fly. They're all good. Come back the next day to get them in. Sort of 6 of them have got fly, and they were the lighter lambs. They didn't go downhill because they had fly. They, in my opinion, they got fly because they were going downhill. And so, yeah, that as long as we kept them reasonably healthy and reasonably well fed and dipped them, but no more than we had to, we didn't have any major outbreaks. Sorry, hang on. Just wait till we got a mic. Yeah.
No, I just, as another trait that could be selected for is resistance to fly strike.
Yeah.
I have been to Merino Stud in Queensland that got all their rainfall summer thunderstorms, didn't dip anything for fly, just not because of the fleece structure.
Yeah.
Well, just in the interest of time, I know there could well be some more questions out there, but we've got this session out in the yards this afternoon that's planning to be relatively interactive, so there is every chance that you'll get a chance to ask more of those questions then. So thank you very much, Robert. Again, appreciate you not only hosting today, but the trial. And we will now shift on to Suzanne and Tricia. So the PAC trailer or portable accumulation chamber trailer is what enables us to measure our individual sheep methane and CO2 levels. Across 3 cohorts of this trial, we have measured a total of 740 animals through those PAC chambers off grass, and just under 600 of them have also been down to the RFI unit to see Tricia, where they've also been measured for PAC off pellets, off loose pellets, where they're also monitored for their feed efficiency and feeding behaviour. So yeah, tell us a bit more about these measurements, Suzanne and Tricia.
Apologies for making you wait to see the presentation, and sincere apologies. I would love to be there. I really would love to be there. I was stuck in a meeting all morning that I couldn't get out of. I should have been on the road, but I wasn't. So I'm now stuck in my office instead of there with you looking at sheep. So my loss. But hopefully I can give you a little bit of a flavour. I thought about this presentation and I thought about the low input trial and what you guys have been doing. And what I really wanted to share with you are some of the opportunities that we have as scientists with the data that you've taken the time to measure and provide. So I really wanted to show what life after the progeny test looks like for us with the data as well as the data itself. So I'm going to give you a handful of slides just on measuring methane, just for those of you who don't know much about it. And then I'll talk about the test itself and the data from the low input progeny test. And then I'll talk about some opportunities that we've got with the data. So can you guys see that video? Sarah, you watching a video?
Yep, it's working.
Perfect. Okay. I won't talk much. I'll just give you a few seconds on the trailer so you can see how it works. Okay, so hopefully you guys just got to see that it's a very simple process. We've got a set of chambers that are known volume, and we put sheep into them for 40 to 50 minutes at a time, and we measure methane, carbon dioxide and oxygen throughout a 50-minute period, and then we release them. And they have quite a strict feeding regime going up to being measured, so as we measure like with like. The gas that comes out of the chambers is converted into grams of methane per day. We adjust the data for time off feed, and then breeding days are estimated by the CIL, or the improved genetic engine, on a fortnightly basis. So the BBs are then available to breeders. What do these breeding values mean? Well, they're an indication of how animals compare for the total methane emissions that they give per day. So we scale up that 1 hour to a daily measure in grams per day, and we rank it back to a mean. So actually your breeding values are based on the proportion of the mean for the industry. An animal with lower methane has a negative breeding value, which is always difficult. So negative breeding value, positive income. But yeah, it's really important to remember that it goes from low to high. The breeding values that you're getting at the moment don't account for feed intake, and they don't account for size of the animal. That means a small animal will give low methane. So they have to be included into some index or have some kind of scaling factor, or you would just breed for small sheep. The reason that they're the absolute and they're not by unit of feed intake or unit of live weight is that would end up double counting in the index further down. So it's an absolute measure of methane emissions. So you should use them alongside your performance BVs. Rank your animals by performance, choose your best animals, and then choose the ones that are also low methane, or you can combine them into an index. But we're really working hard to express them in a way that means that they can go into the environmental calculators and they can be part of your farm environmental plan in the future, should you need to use them. We actually put a value on them. We value carbon at $100 a tonne. We have done for a few years because we've been breeding for low methane in our index for quite a long time. And what that looks like in principle is that a gram of methane less, a daily gram of methane less is worth $6.81 in our index. We tend to, we've been talking to people, I'd say probably half of that, a $50 per tonne for most people would see progress. But we are currently seeing around 3 to 4% progress per year in our flocks by valuing it that way. So onto the low input flock. We've measured 3 birth years and we've done 6 measures because we've measured them on grass and we've measured them on pellets. So we've actually measured 848 animals through the trailer from the low input flock. That's a big data set. That's really starting to get towards the sort of data that, can really give us information on correlations, heritabilities. Geneticists are always whining that they don't have enough data. But you guys have done a really, really good job of measuring enough animals over enough years that it's really becoming something that's very, very useful and very informative, not only to you guys, but also to the rest of the industry. So I'd really like to congratulate you on sticking it out and going the distance and, and getting these animals measured. So we've estimated some heritabilities, and in general, the heritabilities line up really well with what we've already seen in other research flocks. The heritability eating pellets tends to be higher than eating grass, and that's just because they're eating so much more that they can express more variation. But it's really nice to see that the heritability of the carbon dioxide emissions is high and comparable to what we would see in feed efficiency. And the heritability of what we call our pack scaled ratio trait, which I know is a mouthful, but what that's basically doing is scaling the methane by the total gases emitted, because we think that the total gas emitted is actually an indicator of feed intake. So we think that we can use the pack chambers to deliver feed efficiency, but we are really struggling to parameterize that and account for all the sort of factors. So although you're getting a CO2 BV at the moment, you can't use it and there's nothing to do with it until we can really get these models tweaked and where we want them. But that's why you get a CO2 BV, because we think in the future it's going to become really useful. So what did the flock look like? The top flock, the orange is variation in methane emissions when they're eating pellets. And we've already said there's more variation there, and the blue is variation when they're eating grass. The main thing to note here is that there's a huge amount of variation. So as Robert said earlier, it's already sitting in the flocks. We don't need to go out and find some animals somewhere that are from the wrong place, that they haven't been accustomed to the environment. We can actually look within our own flocks and breed from our own replacements. There's plenty of variation in methane sitting in flocks right across the country. We see it everywhere we go. There's also variation in the methane ratio trait, and that's the idea. That's this trait that gives us methane per unit of feed eaten. So when we look at that trait, we're actually looking at something that drives methane down whilst improving feed intake rather than just breeding for smaller animals. So lots of variation in the size that have been measured. And what I've done is I've converted that to the percentage of the mean, which is this column here. I don't know if you can see that. But if you look at the percentage of the mean column, I've ranked them by methane emissions. And the best animal has minus 11% of the mean, and the worst animal has plus 10%. So as I've said before, there's a big variation here. You know, there's a lot of variance and there's a lot of scope for selection, even within the flock. And if I look at the results that we got from the low input and I compare it to the PAC CH4, this was a couple of years ago now, what I basically see is exactly the same result. So minus 0.88 for the top 5% and plus 0.93 for the bottom 5%. So the numbers line up perfectly with what we've seen before. So it's always a comfort when things match. So now I want to talk about what we do with it. I've got here animals ranked by their methane BV, but also by the indices that you've been working with. And I want to look at GMFD, and this is what I expect people to be doing with their breeding values. So here we've got 3 animals, and on the index, they're pretty much exactly the same value. But if I value methane either by $50 a ton, which is this blue dot, or $100 a ton, which is this orange dot, what I see is an animal that would have been down here, stuck in the middle, suddenly pops up here. If I use an index that includes methane, suddenly he's much more valuable than the animal either side of him. So that's what I expect to see when people start selecting for methane. I expect them to be choosing animals that are performing as well as they would expect to select, but just looking for those low emitting animals amongst their top sires. But what's really important is that you don't just measure your top sires. It's really important that we measure everything and that we get a real feel for what happens at the bottom as well as the top of the index. Otherwise, we're going to skew the results. So although we want you to select using index, we really want you to measure methane across the animals that you have. So I want to talk about rumen sampling. I have a project that's funded by MB that's been looking at rumen microbial prediction, and it's been looking at the baseline. It's been looking what the microbes in a gut across New Zealand for all ruminant species look like. So we've collected 11,000 samples. And what I was able to do for this project was to include the samples that we could collect when we measured methane. And then I could sequence them under the MB project. So we could align the 2 programs, which was really nice because I was getting industry representation in my project and you guys were getting all your rumen samples sequenced so we could look at prediction. And we actually collected 1,130 samples, but actually around 500 of them that we used in our research came from the low input flock. So they became actually a really important part of the project. And what we did was to collect rumen samples from the low input project, not only on an old method that we'd been using in the lab for a long time, but on a new method called 10x2, which is a particular preservative, which was going to make everything much faster if it worked. And we were able to include that in this project. And actually it was really successful. What we found is the old frozen method of collecting rumen samples, snap freezing them, freeze drying them, grinding them. I could go for a long time on how hard this process was versus using a lab preservative. We've had a really good result. So thank you for contributing your samples, and thank you for being part of the project. And what that's allowed us to do is to come up with a system that in future will enable people to very quickly and much more easily get a rumen microbial profile. So another thing that we did was look at all of the animals that had rumen samples and all of the animals that had been measured on the pack trailer, and we predicted methane just from a rumen sample. So we ignored any methane, and we predicted the methane just from the rumen sample, and we also predicted methane using the portable accumulation chambers. And what we did was we set up a training data set and we predicted forward to the youngest animals. And you can ignore all of these numbers. All you need to know is that the accuracy of prediction for methane, either using PAC, genomics, or microbes, was pretty much exactly the same. And the genetic correlation between a prediction from microbes and from methane was close to 0.8. So what that tells me is that I can go out to people and I can measure animals with my portable accumulation trailer, and I can give them a pretty decent prediction of methane. But for those animals that I can't get to and that can't have that trailer come up their farm gate, actually we can wander up there with just a stomach tube and do the same job. And the other thing that we found was that we can combine the data. So somebody over here might be using a trailer, somebody over here might be using a stomach tube sample, but we can use them all in the same evaluation. So these are big gains. And the most exciting thing about that is that I can use a stomach tube in a goat or a beef animal or a dairy animal. So suddenly I'm not restricted by the size of the chambers. And we can go across species, and we've been working on that too. So we've got new preservatives in the microbiomes, and you were a big part of testing those. We developed the bioinformatics and the statistical pipelines along the way. We can rank in the same way as PAC, and we can use it in combination in different breeding schemes. So that's a big contribution that you guys have made, and a big impact of the project. And I just wanted to make sure that I shared that with you. The other thing I wanted to share with you was that we are part in AgResearch of a grass to gas project. Now that's a project with 10 partners across 7 countries, and they're interested in the same things that we are. They're interested in feed efficiency, indoors and outdoors, and they're interested in methane emissions. And together we're putting together a data set that can have a global validation of our predictions. And these guys are all buying pack chambers. So this is a truck in Norway, and it has pack chambers inside it. The Irish have a trailer. The Scots have bought a trailer. France has just ordered a trailer. So not only are they measuring feed efficiency, but they're also measuring methane. Uruguay measuring using pack chambers. So they're doing the same things as we are, and the data set that we've collected for the low input flock actually matches with data in other countries, and we can validate with other countries' data should we choose to. We haven't put the data in yet. It's a conversation with you guys, with Jason, with Dan, but there is scope to be part of this project, and to go forward. And basically to share in this global impact. And finally, this is my last slide, because I know I could talk forever. We're working on a field testing centre at Woodlands, and it's called -40 by 40. And what we want to do is stack everything we know to see if we could hit a 40% reduction in greenhouse gases by 2040. One of those really important technologies that we intend to stack on is management. So then we think about survival, we think about efficiency. So my challenge to you guys is to give us what you think was really, really important. What were the really important findings from this trial? And we'll look at how we can incorporate it into the -40 by 40 program to make sure that we keep driving all the good work forward. Because it's really important to us as scientists that science doesn't stop, that we keep going, and that we serve you as well as we can. So conclusions: your size range from +10% to -10% from PAC, and there was lots of variation to select from. But through collaboration and alignment, this project's made a big contribution to tool development and to knowledge gain nationally. So again, thank you for that. And finally, a plug. I'm looking for about 15 breeders that are genotyping with genomes to be part of a beta test to get breeding values from rumen microbial profiles. So if you want some free methane breeding values and you're prepared for us to come up your drive and stomach tube some animals, then give me a call, and we'll see what we can do. And that's it from me.
Thanks, Suzanne. I'm sure there'll be a bunch of questions after that, but just a quick note. I know some of the numbers for you here physically might have been a bit small to see. So if you do want to go back, obviously this recording will be made available to you so you can actually look at those numbers in more detail if you want to at a later date. But again, thank you, Suzanne. I don't think we've had anything come through online, so the floor is yours, guys. I might kick it off actually, Suzanne, just from a breeder point of view. If I'm a breeder interested in testing my flock for methane, where do I go and what do I do?
So there's a website, methanebv.co.nz. So if you pop onto that website, there's a form, and it's basically an expression of interest. If you fill in your details, it'll come through to us, and somebody
we've just lost your sound, Suzanne. Sorry. We can hear you again now, Suzanne.
Oh, very good. Yes, methanebv.co.nz. There's basically a website, and any of the beef and lamb guys can share it with you. They host it. If you go on and put an expression of interest in, someone will call you, and we can take it from there.
Okay, I have two questions, but they're both for beef and lamb, actually. Is this the right time to ask? Righto. So breeders are going to be wondering, is there an option now for breeders to use rumen sampling for their prediction of a methane BV? Or where do beef and lamb sit on that one? And the other question is, AgResearch have this economic weighting for the methane BV to incorporate into an index of -681, I think it was. Just wondering what beef and lamb's thoughts are about that, and if there is a timeline in place for us being able to include the methane BV in an index of some sort.
Is this on? Yeah, these, no, the rumour sample BV, sorry. I actually can't answer that. I guess that depends. I don't think we have it in place. Suzanne's probably got a better idea of when that might be ready to roll out. So I'll throw back to you, Suzanne, for that one.
I can tell you that we have the capacity to do it ourselves as a research trait. It'll be a conversation over the next year or two with Jason and the guys and David to see if it's suitable to roll into the system and whether we trust it enough. So we'll beta test it first outside the system, and then in time-honored fashion we'll roll it in if we trust it.
Yep. So there might be some research BVs available directly from AgResearch for the people that you work with on a trial basis, Suzanne.
Yeah.
Question. Yep. An index. So right now we really just need to solve the issue about how that BV is best expressed. And Suzanne talked, so it's really that issue around selecting for, if you just look at methane, you're selecting for smaller sheep and how that all works. And then we have Abacus lined up to, as soon as we press go, to put that work into an index. They have already started some work on that, but we sort of came across this stumbling block because we also need to understand how that will go into calculators, and those calculators don't exist yet, is the issue. So it's coming, but it's not here just yet.
Yeah, I've just a similar question. So the breeding values from the pack chamber, will they be available any sooner than the breeding values from the rumen samples?
So they are available now.
So we can ask our bureau for
yes.
It's not a research BV, it's a commercial BV.
It's in production.
Yeah.
You can do that right now.
And is there a minimum, like if you do 1 year's testing, do you get breeding values straight away, or do you need a couple of years to make a bit of accuracy in the data?
Oh, you can get breeding values up straight away.
Right.
Obviously, the longer you've done it, the more accurate they get.
Yeah.
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 You'll get, I mean, when you pack test, you are choosing lambs to, you know, a random selection of lambs to represent your sires. So those sires will get a reasonable accuracy straight away, pretty much.
Yeah.
And then you obviously build your database as you go, just like starting Dags scoring or any other trait.
Yeah. And also on the genomics, so obviously genomics is a big part of this. There's a certain number of breeders, and it's often the same breeders every time there's a new trait, put their hand up first, do a fair bit of work. Then there's a breeding value available. Then someone else comes along who's done no measuring. Will they be able to get a breeding value just by doing a DNA test and feed off our hard work?
Yep, so really good question. And the issue you talk about, if you take a trait that everyone's paying for themselves, like facial eczema, is a really pointy issue, and we restrict breeding values for that trait based on exactly that issue that you're talking about. For methane, you know, beef and lamb has subsidised that measurement up until now, and actually that subsidy is going to even increase in the future, or from pretty much has increased. And so there's a lot of public investment that's gone into that. Public investment, by public I mean, well, one, government money in the back to develop all this, and then secondly, to actually pay for those phenotype collections. So we think it's reasonable that actually people can access that. Yes, you've done the hard work for the breeders who have done it, but you will also get that first mover advantage because you'll have the actual phenotypes yourself as well as the genotypes. So we do intend to make that available as widely as we can in the industry to solve this issue as a collective at scale as quickly as we can.
It wasn't a huge subsidy, because although it was a subsidy, we still had to pay for the DNA to get the subsidy, which was about the same cost.
Yeah, although the DNA gets you a whole lot of other things at the same time. Yeah. The subsidy from now on is going to be 100% of the phenotype measurement. And we're also looking
on the condition that we DNA them.
On the condition you DNA them. And we're also looking at subsidising some of the DNAing for sires in the future.
Hamish Belsky. I know how hard it is to breed a sheep with productive traits, and then you add on Dags score, body condition score, worm feck, bear breach, and the list goes on. And as a commercial farmer, I want to improve my productivity, increase the weight of my ewes now, because we need to grow faster lambs, and we need less dags. We need so much more to our sheep now than we did 20 years ago. I guess my question is, what can we see the correlations between the methane and all these other traits, so that we're not going to be selecting negatively against a whole lot of other traits that we've spent so many decades trying to breed for?
Can you still hear me? Yep. So a whole heap of work has just been published on all the measurements on those traits for the last 10 to 15 years. So there's tens of thousands of records, and the genetic and the phenotypic correlations for meat traits and for maternal traits, for feed intake, for feed efficiency, have all just been published. So they are available to you, but I will talk to Jason about how we can perhaps sum up some of that published data and make it maybe more readily available. Jason, does that make sense? The short answer to the question is there's very, very little. There's very few traits that are related to methane. The feed traits are obviously related to methane, and fatty acid profiles, and you tend to get slightly less fat on a low methane animal, and there's a significant correlation with wool. So low methane tends to be higher wool. Other than that, there were no real correlations between the productivity traits and methane emissions.
Okay, so just on that, the two of our biggest traits we're after is body condition score. So we need fatter sheep, and that correlates with IMF, etc., for meat eating quality. And wool weights, we are strongly selecting for lower wool weight. So I'm not quite sure how this is all going to stack up in reality. I know it works on paper, but we'll see.
So basically then we start looking at index selection. We've been incorporating methane into Flock 263 for the last few years down at Woodlands. And we're still improving all of our other traits whilst reducing methane. So it can be done. We just need to make sure that we get the index right.
And I guess the other comment I'd make, Hamish, you're absolutely right. That's the challenge of animal breeding, always has been, is how do we do multiple things at the same time? How do we deal with antagonisms? How do we take advantage of favourable things? So the framework's there to do it. It's just the more things you want to do at the one time, probably the less we do in any one thing is the challenge. Yep, and that's what indexes are about. I guess the other thing I'd say, and this sort of comes out of a conversation that we had in the car on the way down, so this is Sharon McIntyre's thoughts really. We can make better use of reproductive technology in the sheep industry to accelerate genetic gain. And we should be looking at that as an option.
Yeah, well, my question was probably really back to you, Jay, or beef and lamb, and it's to follow up Robert's one, is the hard work that goes on by particular breeders to do the raw data and all of that, and then through genomics, people, I guess other breeders, other thing, but part of your education you mentioned earlier is to make sure that that is explained, that there is a slight difference between actually that phenotypic and raw data, and then followed through to just genome sort of data, that there hasn't actually been any real raw data collected off, but people are, from a marketing perspective, are certainly taking advantage of it.
Yep, it's certainly an issue. I guess, genomics is really about increasing accuracy, and accuracy on young animals more quickly than having to wait to measure them. Unfortunately, right now, we don't actually have the technology to reflect that in the accuracy figures. So the accuracy figures that you get in your analysis are actually only based on the phenotypes. And the labs would love us to actually be able to account for the genotype part of it, which we can't do yet. But yeah, so some of that will be reflected in the accuracy of the figures.
Two questions. One, for animals of a given live weight, what is the variation in methane production? We've talked about from +10 to -10, ignoring live weight, but I'd be interested to know what that is for a specific live weight. And the second question would be, in those animals, is the difference in the methane production, is that because of the genetics of the animal itself, or because of the makeup of the rumen microbiome?
That's a really great question. So the variation when we look at any particular given live weight is pretty difficult, because we scale from food. What we scale from time off feed. What I can say is that when we run animals of very similar live weights for a sustained period of time, we still see that variation. So the variation, if you plot your animals and then you plot their live weight, the variation that we see in methane isn't explained by the variation in live weight. But I can't actually give you a precise figure on that question, and I should be able to. So thanks for the question, because I'm going to go away and calculate it right now. The second question was, sorry, do the microbes explain the methane? Was that the?
Yeah, I'm just wondering whether the variation in methane output is explained by the sheep's genetics, or by the microbiome in the rumen.
So the answer is, if we use sheep genetics to explain methane, we get a prediction. If we add the microbial information from the animal, we get a more accurate prediction. If we just use the microbes by themselves, we get a similar accuracy. So the accuracy is similar whether we use the genomics or the microbiome. And if we stack the two together, we get a jump.
So I'm just wondering about the possibility of putting, transferring the microbiome from these methane efficient sheep into some highly productive sheep, which otherwise were high methane emitters.
So we don't understand why, but there's something to do with either physiological signaling or the shape of the gut or something, which means that if you transfer a microbiome from one animal to another, it reverts back. So transplants in Crohn's patients have worked in very specific cases, but in general, your host controls your microbiome, and we don't know how. And I'm getting signals from Sarah and messages from Sarah telling me to wrap this up. So I'm sorry, but if you want to put more questions in the chat, I will sit here and answer them in the chat for you guys.
Yeah, thank you very much, Suzanne. Appreciate that. Sorry to rush you. I know it's an exciting topic that everyone's quite interested to hear more on. But now I'm going to pass over to Tricia Johnson to share with us some insights around, residual feed intake.
So one of the things I want to kind of start the presentation by talking about is that I am talking about feed efficiency. The word efficiency has a whole lot of different meanings depending on what context we're talking about. We can have people talk about a maternal efficiency of the weight of live weight weaned per kilo of live weight ewe mated or at weaning. There are so many different ways that we can express efficiency. They all have their relevance and their place and their importance in how we manage and think about our commercial production systems. But the trait that I'm talking about today is very specifically feed efficiency. So feed efficiency can be expressed in a number of different ways. Jason Archer, who's here from Beef and Lamb Genetics, actually did his PhD and post his PhD of doing a lot of cattle efficiency work and feed efficiency. And there's a whole lot of different ways that it can be expressed. But the trait that we've been concentrating on over the last coming up decade now is to think about this trait that's called residual feed intake. And the whole concept behind residual feed intake is, do similar animals eat and need the same amount of feed for their production outcomes? And when we think about similar animals, we're thinking about that question that just before of an animal that's the same live weight and potentially growing the same weight. Do different animals who are 50 kilos and growing at 200 grams a day, do they eat and need different amounts of feed for those productive outcomes? The answer that we had from the cattle literature and other studies is that it's more than likely not. But we really, a decade ago, knew nothing about this in sheep, and particularly from a New Zealand context. So back in 2015, we ultimately established a feed intake facility at AgResearch Invermay. So what we have within the facility is 20 of these feeders, and we can see the animals going up into here. In some ways it's easier to see with this girl here, is that she has her EID, and this is an EID panel reader here. We have the lucerne pellets that are sitting within a feed tray. This is on a load cell. When she comes in, her EID is red. It timestamps when she comes in. We know how long she spends in there because when she leaves, it's also timestamped. And so we know how long she was in for and how much feed she actually ate for that feeding event. And across the day, we kind of sum all of that to get the total amount of feed she ate within the day and the number of times she went and how long each of those feeding events actually took place for. So we're capable of running, each feeder can kind of happily look after about 10 sheep a day. And so we can house up to about 200 animals within the facility. So the initial project that we did was the Beef and Lamb Genetics Feed Efficiency Program that ran between 2015 and 2018. And we put nearly 1,000 animals through the facility, sourced from the Central Progeny Test and 2 of the flocks that we have down at AgResearch Woodlands, being the flock 2638 and the greenhouse gas selection lines. What we could see within that resource is that for animals that were similar live weight and growing at similar rates, we could see up to a 22% difference in how much feed they were actually consuming to actually achieve those outcomes. This number of 22% was achieved in our first year and was very consistent with the literature. And so we had confidence that we were measuring something that was consistent with the literature and we could kind of proceed. So we ended up with I need to cross the word very high out. It's a high. I've got some very high coming up in the next presentation. Heritability estimate of 0.42. So this is telling us that this feed efficiency trait is a very heritable trait where we are seeing a lot of genetic variation. So this work kind of concluded in 2018. We didn't have any animals through in 2019 from these resources. But from 2020 onwards, we had 3 cohorts from here at Orari Gorge, came down to McRae and went through the facility. So this was actually the girls coming down and going into the facility. What we do is that the girls get trucked down from Orari Gorge. We enter them into the facility. They take about 2 weeks to adapt, and I've got a slide in a minute from one of our favourite or not so favourite cohorts with a bit of an outlier, but generally within about 2 weeks we find that they start adjusting to eating the lucerne pellets really well. So we also do an ultrasound scan for measuring eye muscle dimensions as well as fat depth over the eye muscle at the start and the end of the period, and then we go ahead and have a 42-day measurement period. The cattle protocol is a bit longer, but we find within the sheep industry that the intakes actually stabilise over about 21 to 25 days, but we need that full 42 days to actually get the growth rates, to actually really predict what the live weight gain on those lambs is, because any 2 successive live weights, she could have just had a massive feed, or she could have maybe not had a feed since the night before. And so when we're trying to accurately predict live weight gain, we need lots of data. So these were the animals that we had down here in 2020. They were the Born 19 cohort. Our farm manager at the time, Kevin Nola, had put 1,500 animals through the facility at the time, up until these girls came through. And he was getting towards day 10 of that introductory period, and he just had a whole lot of problematic animals that were just not eating, and he was getting quite frustrated with them. It turns out that they were mainly all from the same sire, the sire here. So by the end of that 14-day period, the proportion of the animals from that particular sire that were eating over 1,000 grams of those pellets per day was only about 30%. Whereas for most of the rest of them, they were getting up well in that 0.7, 0.8 or 70 to 80% of them eating really well. So this sire turned out to be a sire that had a really strong selection history for parasite tolerance. We would love to have done some follow-up research with those particular lambs, whether this was actually a picky eater and that somehow thought those lucerne pellets were actually going to kill them. Once they actually got onto the pellets, they actually grew exactly the same as any of the other animals on average within the facility, but it was just a really interesting outcome. Do we have a health and safety issue, or are we right? No people are down. So if we look at, so we've had kind of Born 19, Born 20, and now we've had the Born 21 girls come through the feed intake facility. As I said, we measure the ultrasound fat depth at the start and the end, and we can see that they put on nearly 2 mils of fat while they were in. Their starting weight this year was about 39 kilos. By the time they left, they were at 53 kilos because they were growing on average 272 grams a day while they were in the facility. So they were growing well. Sometimes we see them up just over the 300 mark, but at 272 grams a day, we're really giving them that opportunity to express their growth potential. But we can see down here that the range was 72 grams a day through to little Pudgy over here growing at nearly 400 grams a day for her time in the facility. The trait of residual feed intake, you get a mean of 0, but this is the value that we're interested in over here, and it's the variation that we see. So just to take through and to think about the variation that we're seeing, I tried to choose out a bunch of animals that were roughly the same live weight, a little bit of variation, but only within a kilo or so, and roughly, always hard to find perfect matching pairs, but roughly growing the same. But what we can see here is what their average intake is. And if we take this pair of animals here, this animal that was 46.5 kilos and growing at 258 grams a day was only eating just under 2 kilos of those pellets a day, whereas this animal down here, very similar production outcome, was needing 2.5 kilos of pellets a day to achieve that same outcome. So that's a massive difference in how much feed those animals were needing to actually achieve those same production outcomes. These are the extremes, but there were quite a few examples where we can see. So anything that was kind of in green was needing considerably less feed than those in the oranges and reds to produce those kind of live weights and growth rates. This is an example from last year's data set that we had through here. I picked 2 sires who had similar growth rates. It's hard to get a 3-dimensional graph, but so similar live weights, and the lambs of a low RFI or an animal, a sire whose progeny are eating less than they should or predicted to, are in blue, and the ones there are in green. And so if we look kind of around that 50 kilo live weight, that improved feed efficiency animal, or low RFI, another one of these tricksy ones to get it around the right way, was needing to eat about 2.3 kilos of feed, whereas the one that was inefficient, or the high RFI, was sitting up at about 2.6 kilos of feed. So 10% difference there at the sire level in terms of how much their progeny were needing to eat. Some of the really other interesting traits that we actually get out of the feed intake facility, I said earlier, we can see how many times they go into the facility or into those feeders, how long they eat for, and how much they're eating per feeding event. What we find is that there is a massive number of behavioural traits that actually come out of this particular facility in terms of seeing how the animals are actually consuming their feed within the day. So this is an example where we have a low rate feeder. So she will be in the facility for 500 seconds and she's only eating about 100 grams of feed. Whereas this girl over here, for 500 seconds in the facility, she's eating about 300 grams of feed. And the fact that all of her data points are roughly sitting on a same line and all of hers are sitting roughly on a similar line is telling us that this rate trait is an innate pattern or behaviour that those animals are eating within the facility. Some of the other feeding behaviour traits that we observe is the number of times that they go in. So each one of these represents 42 days worth of feed intake data for 2 individuals. This girl down here only going in somewhere between 10 and 20 times a day into those feeders and tending to have quite large feeding events. Whereas this girl over here was going in on average about 50 times a day, but on one day she actually went in 100 times into those feeders. So completely different behaviours in terms of how they're accessing their feed and how they're wanting to achieve their feed intake over the course of the day. If we think about so these are all kind of a little bit similar. This is the average intake. This girl down here is most likely this girl here, I think it was. I forgot to swap the colours around, is that she was only having kind of 10 or 20 gram feeds. Whereas this girl here is in there having up to 100 or 200, or one day she just sat there and ate 800 grams of feed in one feeding event. So again, with the duration, it shows a very similar trend. What these traits mean, as a farmer who winter feeds and break feeds over winter, you always give animals a first allocation. If you have those animals that can kind of go in and have those really big feeding events and are happy to kind of gorge and consume, they're going to get the best out of that first break of the winter feeding season. Whereas if you've got this girl down here who would rather nibble her way through the day, by the time she gets to the end of that day, is there any quality feed left? But the really cool thing about the low input progeny test for me, and again, as everybody has been saying, I commend everybody who has been involved in it, because what this feed intake part of the program has enabled us to do. I said that we had the trait data from the first 1,000 animals. We recently, Suzanne mentioned, we've just done 3 publications. That was part of one of those publications. So this was the BLG progeny test data set here. I had a heritability estimate there of 0.42 for this residual feed intake or feed efficiency trait. It's always great to have a value, but you always want to replicate it and actually see that it's kind of repeatable under similar conditions, but different groups of animals. So the low input animals gave me the chance to kind of work my way through all of these traits and actually estimate independently the heritabilities for all of the traits that we have, including those kind of feeding behavior traits, and then to kind of combine them all into one. But the thing that really excited me when I hit solve was the fact that I got a heritability estimate for the low input of 0.43, matching with my 0.42. From a stats point of view, this extra number is just our kind of accuracy we have with it, because we had slightly lower numbers here, it was a bit higher, but I was able to really happily combine it and get a really strong, solid estimate of the heritability of this feed efficiency trait by combining the 2 data sets together. When we look down here at some of those feeding behavior traits, you can actually see they're really heritable. What they mean and how we could use them. We do know from, and it is published in one of the papers, is that there is a little bit of a relationship through to methane. It's not a be all and end all relationship, but that those that have the low methane do tend to have a slightly different grazing pattern of maybe having those smaller feeding events. But we've got all of the data to kind of work through again. We haven't done the next step of combining it with all the methane to re-estimate all of the genetic correlations with Suzanne's methane traits, but it's on our list. So where to moving forward? Putting animals, we've already heard Robert say, putting animals through the feed intake facility at McRae is expensive. It's about $400 an animal. It was less than that when they put their animals through, but we're looking at about $400 an animal now to get this amount of information. But so what we're wanting to do is, and Suzanne mentioned about the work that she's been doing with the rumen samples and actually being able to predict methane levels. She's also been working, and the team have been doing an amazing job of actually considering some of these feed efficiency traits as well. And we can see that rumen microbiome is actually explaining quite a lot of variation that we're seeing in feed efficiency. Whether we can kind of take it through and take it out to pasture is one of our other things, as obviously this is in a feed intake facility and not at pasture. But so what we also have is a program of work looking at, so this is a little accelerometer that we mount under the jaws of the animals, and it kind of really accurately describes and measures the biting and the chewing. We can pretty quickly and easily see now when an animal is eating or not, and that's kind of been published by the Australians already. But what I'm really interested in is the Australians don't take account of that rate difference, the fact that some animals are really fast eaters and some are just nibblers. And so can we use any of the signal that comes from these to be able to actually help us accurately predict feed intake off pasture, so that we can kind of have some kind of validation of what we observe in the feed intake facility, together with some rumen microbial profiles, together with some in-paddock information. So in summary, the results that we've obtained from the feed intake facility and using the low input animals have really consolidated what we learned in that first beef and lamb genetics program. I haven't put up any of the sire results, individual sire results in this presentation. I'm not sure if they're going into the public report so people can look, but I didn't want people having to squint and try and figure out who was best or worst on the screen. But what we have shown is definitely that similar amount of genetic variation. But we do recognise, and this is part of that program of work that Suzanne and I are involved in with the Grass to Gas international program, is looking at some of these proxies to be able to enable that broader scale uptake, because we can think about methane directly as being the amount of methane that the animal's producing, but we know that methane is also a byproduct of feed intake. So if we can have these animals that are eating less feed, is that another way that we can achieve some of these reductions in methane that we need to be targeting? And with that, over to you, Sarah.
Yeah. I had a question from Kate Broadbent, but you've actually just answered it around what if grass to gas is looking at feed efficiency, where are we going? But you've just summarised that beautifully. So thank you for that. Any questions from the floor?
Thanks, Trish. Have you got any correlations between all the other traits? Because it's great that you've had these on, you know, I'd like to see those graphs that say, because in my mind, I think I'm trying to select a sheep that goes into a paddock on a rotation that eats a lot of the high quality feed first, because they will retain their body condition versus the one that nibbles away and gets the poorer quality feed at the end of the break. Same with the winter feeding, same scenario, but on pasture. So very, very different results can happen in reality versus the chambers. So have you got those correlation results?
No, so what we do have, and Suzanne kind of alluded to it, and we're going to now work with Jason to kind of summarise what we have from those original 1,000 animals, as well as probably pulling in these next 600 will be our next paper of pulling in all of Robert's on-farm data and actually looking at some of those correlations. So I don't absolutely have it, but it's kind of there a little bit in what we've published already, but I do think there's some more relationships and correlations we need to pull forward. So work in progress.
Yeah, my question was quite similar. Was there any correlation that you noticed between RFI and feeding behaviour?
No, so there was a much stronger relationship with the methane traits than there actually was with that feed efficiency trait. So I think within the paper there are some correlations, but it wasn't enough for us to go, oh, we've got a predictor of just measuring those behaviour traits. So no, the stronger relationships were with behaviour through to some of those methane traits.
Yeah, I was talking to Jason earlier about feed efficiency in cattle, and like at first glance, it looks sort of like the Holy Grail. They eat less, but they still do well. But Jason was talking about there are possible downsides in the cattle industry. They tend to be leaner if they're.
We haven't found that relationship in sheep.
Right.
I don't know why, but we don't have that. One of the things that we do, and it's in some of the analysis that I do, is that we do know that to lay down lean requires less energy than to lay down fat. But once it's laid down, that kind of sits there unless it's being used by the maternal ewe or something. But just in a standard situation, fat's kind of inert and not requiring energy consumption to maintain it, whereas that muscle is quite metabolically active. And so what we actually tend to find is that our more efficient animals tend to be a bit fatter. So it's quite different to the cattle one, and it's so biologically unknown. Jason's gonna go back into it.
That sounds almost too good to be true. But are there any downsides that we need to be aware of?
No, I mean, probably the things that we do need to do is to pull through things like hogget mating information, because that is one of the things with puberty onset in the cattle and everything. So we need to really pull again a lot of that on-farm data through.
Can I ask a question?
Okay, thank you. Thanks, Tricia. Really interesting stuff. I've got a couple of questions about the inefficient animals. Do we have any idea? They were taking the energy in. So what were they partitioning it to? Do we have information about more walking activity or higher heat output or something like that? And thinking further on that, those live weights that you had up there suggested animals that should have reached puberty. So if there were animals in there that hadn't shown estrus for any reason, so they're not wasting any, having one of their little restless days?
Well, so we tend to measure them kind of July through September. So we're not kind of in that, even if they have hit puberty or not. But I do think it's worth us trying to pull some of that data through In terms of that energy expenditure question, one of the things, and it has been a little bit outside, I've just got to figure out how to pull it together, but you'll see here that this girl has that was the accelerometer. That is a GPS collar that we have as well. And so we did a trial, we've done a few trials down at Woodlands, what you would class as being relatively small paddocks in the scheme of a hill country farm. And we were observing that some of the animals were walking on average only about 1.7 kilometres a day. So I was calling them my sloths, through to my ultra runners were running, they were walking and exploring up to 5.4 kilometres a day. So we actually had threefold differences in how far they were actually walking. If anybody's interested, I did publish and present a paper about that last week at a conference, so I can send that through. But so that is something that we do need to think about. Can we actually identify some of those other sinks as to why they're needing more energy?
Okay. Tricia, you've probably heard of boarding school behaviour, which the people that went to boarding school here probably know, but you learn to eat real fast at boarding school, apparently. I didn't go to boarding school. Do you reckon these sheep that sort of gorge themselves, do you reckon that behaviour would persist under that break feeding scenario, or would they actually learn, or the other ones maybe learn to get into it and catch it?
I don't know. It's interesting because they exhibited these behaviours from day one in the facility. So it's something they've come to the facility with. So I don't know. Another paper that I presented last week, though, was we followed some ram lambs through. COVID meant that we couldn't kill them when we wanted in 2020, and we followed them through the winter and had half of them on growing at about 170 grams a day. So they were kind of on an ad lib winter feed, and we tried to have the other set grazing just above maintenance. So we were targeting about 50 grams a day, average 28, but a third of them actually lost weight. And so that was that kind of, they were kind of doing that winter grazing where feed wasn't particularly good. They were being kind of not quite break fenced, but certainly feed wasn't ad lib. Those ones that are on that just above maintenance, and some of those went backwards. So whether this explains that, we don't know, and we kind of need to do that experiment where we fit them with every gadget under the sun, and kind of repeat that kind of experiment. So.
Hi there.
Hi.
Sorry, this might be a silly question and I might have missed something, but in the RFI you were using just lucerne pellets.
Yep.
Like, do you have any idea, like, that heritability, like, of that trait, whether it would be consistent across different diets? Like, if they grow really well and don't need to eat much, like lucerne, whether like it could be like the opposite way in individuals on, grass or whatever.
Yep.
So that was question number one. And then I did have another question, but I'll maybe listen to the answer. And see if I remember.
I mean, the first question is one that we always get, like, how is measuring these on lucerne kind of relevant to the hills here at Orari Gorge or anywhere in the country? We do know, and we did do an initial pilot study that showed that there was a relationship between the amount that they were eating of cut and carry grass with the lucerne pellets. So we kind of did an initial pilot validation. Ideally, and again, this is Tricia's long wish list in her science life, is to really have those animals where we can go through and talk. And whether and we've got the data and we just need to spend more time looking at it, as Suzanne suggested. Can we use that CO2 measure from the pack trailer? Can we use something like these little devices here to predict intake, or is there something here in the rumen microbiome so that we can do that large scale comparison between the lucerne and at pasture? But the fact that we see so many of those traits kind of establishing very quickly when the animals enter the facility kind of does suggest it's something that the animals have come into the facility with in terms of their requirements and needs. So,
and then I've remembered what my other question was.
The other question was, these was obviously in like growing animals. Like, have you followed them through in terms of like maintaining body condition score and like, into like adult?
Yep. Once again, I think that's in a data set we might have just requested from BLG, because one of the things is, as we kind of heard from Robert, that some of them are only just kind of getting into their first and second lambings. And so we've kind of only just now got to the point with that first 1,000 animals that we've actually got their full kind of lambing set of records and adult sets of traits. So now that they've kind of, those first 1,000 have coming towards the end of their productive life, to pull all of that data and together with that methane data and really tease out some of these relationships. So I know that I've got a lot of unknowns in this, but we've got some pretty cool results at the same time.
Yeah, it's such an interesting scope of work, and it just, from your point of view, obviously keeps expanding because we keep asking these questions, but it's been really interesting from our point of view, at least, watching these animals go through the unit, and as you can see, some pretty massive variations between them. So yeah, that's been really good. Thank you, Tricia. First up, we're going to hear from Tricia on, I think, tails and bear points. Then we're going to hear from Kathryn McRae on pneumonia and wormfeck, and then we're going to be following that with Ginny Dodunski, who will also be talking on wormfeck after that. So I'll hand off to you, Tricia.
Yep, should be good. So quite a different change of tact from what I was talking about before, afternoon tea. And this presentation is again using the amazing resource that the low input data set has generated to look at the role of genetics and the role it has to play in short tails, bear bums and bear tums. So we kind of have seen some similar photos already earlier, but these are the kind of scenarios when Robert was talking, if we can't go ahead and tail. We've already had the regulations around the caudal fold length. Whether we get to the extent of never being able to tail, there are some European Union markets, I think it's Norway, where they forbid tailing. So there are some examples already in the world where tailing is forbidden. And so whether we're on that pathway, I'm not actually sure. But irrespectively, as he said, the team want to go on holiday on that kind of day. So we want to be able to actually think about mechanisms and ways that we can do it. I confer, and I don't know if he said he's hiding. We actually have in the audience David Scobie, who is a scientist from AgResearch based at Lincoln. This was a paper done in 1997, which was why he was asking the questions earlier of why didn't we start this kind of work 20 years ago? So back in 1997, this was a paper that Scobie and his colleagues Dennis and Andy Brier wrote around the ethically improved sheep concept. And it was around this concept of these bare bellies, bare breech. We've heard Russell Welsh talk about the sheddy tails. That's not part of today's conversation, but they do sit there as one of those traits. To start with, though, to think about tails, and Robert and Russell have already mentioned about this a little bit, tail length actually varies significantly between breeds. The Finnish landrace has a very short, thin, kind of rat-like tail. Gotland pout, not that there's many of them in New Zealand, but this is an example of a Gotland pout's tail here. And the Texel and the Dorper both kind of have quite short, stubby tails. And this was kind of some work that Scobie did back in 2007, looking at the distribution. So this was the Finn here, the Texel here, going through to the Wiltshire actually having quite long tails. This is tail to hock percentage. But some of these photos here, I just wanted to acknowledge Daniel Wheeler, who couldn't be here today, who is a very strong proponent of some of these traits and thinking about them. So Robert had on his list of traits that he was talking about is that as part of the low input progeny test is that tail length is measured. So tail length is the kind of full length right to the end of the tail. But this bare skin trait is another one. So clean skin. So this particular animal was kind of down at around 80 millimeters for its clean skin, through to the tail length through to here being about probably 28 centimeters or something like that. I just want to note and point out, because I presented this yesterday and there was a little bit of confusion with the MPI tailing regulations at the moment. It's not actually about the clean skin here, the end of the clean skin. It's about the caudal fold, which is actually this part. Can be discussed later, but they did actually look at quite a lot of the caudal fold information from here at Low Input last year. I think Jason's the one that can think about some of those things. But so this was the kind of information that has been being measured consistently, of that clean skin and that tail length. Tail length can be recorded in SIL as tail length score, one being short of less than 15 centimetres, medium being 15 to 25, and 3 being longer than 25. So this one would have probably just fallen into that long category. The other traits that Robert said that they're scoring here, I think you'll actually find that the David Scobie overalls in the background of this photo, or Dennis's, is to start with an animal that is kind of very full-walled in terms of breech Brier score, right up to the everywhere, through to animals that actually have quite a bare area, kind of right down the legs, right up through that breech area, and kind of somewhere in between. Very similar with that bare belliness score trait, an animal that is kind of full-walled, having a score of 1, through to animals that have a really nice bare belly, right the way through, kind of right to the area, having a score of 5. So one of the things, and Robert talked about this, what the Low Input Progeny Test has done has allowed a number of flocks throughout the industry have been collecting these traits over the last number of years to actually achieve connectedness. Because they tend to be breeds of different breeds, as Robert had up, he's had everything from Perrindales to Wiltshires to composites to everything going through here. Because so few breeders were actually measuring these traits, it was very hard to actually have a decent connected analysis of them. And so the Low Input Progeny Test has really enabled that kind of genetic connectedness for a lot of these traits. And so what we've done in the last 6 months is bring together all of the flock data that has anybody that's kind of been measuring these kind of bare points or tail length traits, together with the low input data set, together with the central progeny test, that's really allowing us to have that genetic connectedness, that we can look at the genetic variability in these traits and kind of give some hints as to where the future might be for some breeds and these traits. And so this is the number of flocks that we had within the data set that we're able to look at. So at the time that we had this, we only had 22 flocks that had proper tail length score, tail length measured, and tail length score on a further 5 flocks. This column here is kind of the number of flocks times the number of birth years to give an idea of the depth of data. So the fact that that's less than 100 would kind of suggest that most of these flocks have kind of only been doing it for several years, not tens of years. Whereas tail length score down here, it is very much that some flocks have only just started measuring tail length, and instead of having to do full tail length, they just opted to do the score. Less have been doing the tail skin length underneath, but because it's kind of a combination, it was interesting. There were some breeders that did tail length score, but then they actually measured tail skin length. So the numbers kind of don't ever quite add up. And then going through into the bare breech, bare belly, and Dags score. We have down here 2 Dags score traits, and Kathryn will talk a little bit more about those traits. I haven't really featured them in the presentation, but we recognise that in some scenarios, the animals haven't actually had particularly good enough challenge to actually measure Dags score. And so you end up with the flock average being very low, below 0.5. And so in those cases, we've kind of censored that data out to flocks where they've had a decent challenge and there's actually a bit of variation in Dags score. So If you actually go back to some of Scobie's work, it's a little bit similar to what I've done with the feed efficiency work, is comparing kind of the results that we had from historical data sets to new data sets. The results that we've got for this particular data set show that tail length trait is actually, I said, highly heritable for feed efficiency at 0.42. This puts this into highly heritable, about 0.63. One of the things I did in this particular analysis was actually adjust for breed, because there were those questions of, well, is this actually just comparing Romneys or Wiltshires with Texels and Finns? But what this is actually showing us is that there is breed differences, which I'll touch on in a minute, but that even within accounting for breed, that there is still very significant variation in that tail length trait. Could be argued that that's coming through in some of the composites, but even so with those composites, we still had a breed prediction that we were able to fit. That length of clean skin under the tail, 0.52, again, very highly heritable. Expressing that tail skin as a percentage of the overall length, highly heritable. Bare breech and bare belly, again, very heritable traits. Because we had so many data points, these standard errors or estimates of accuracy are pretty close to zero. So this means these are really good estimates in telling us that these traits are really highly heritable. But, and there is a but in this story, this trait over here, CV, is the coefficient of variation. That tells us how much variation we actually have within a breed for these particular traits. If we think about the trait of tail length, we can see here our Finnish landrace have a very short tail on average, 13.6 centimetres, but they have relatively little variation, only about 14% variation around that mean. Probably not so much of an issue because we've also already got some pretty short tails going on here. Texels have the next shortest tail, a little bit more variation to potentially go through in those, and potentially, as was commented before, a lot of these are probably not pure breeds. But so there is a bit of potential within the Texel breed to be selecting for shorter tails. But if we look at the Romney here, they had the longest tails and there was actually very little variation in them. It doesn't mean that no progress can be made. It just means that it's going to be very slow progress to actually make genetic progress in shortening the tails in a breed like a Romney. In terms of tail skin length, very similar in that we have not similar, that we have a bit more variation coming through in the Romney for that particular trait, but relatively low starting point, that they had very little clean skin under that tail, whereas the Finnish landrace up there did have quite a lot of clean skin under the tail, but it did in this case actually have quite a bit of variation. So there's still genetic progress and improvement that could be made in some of these breeds. If we go through to the bareness traits, beech bareness, I don't think it's any surprise, but so this is those animals. Ones were the ones that were kind of full wooled, through to 5 being kind of full bare breech or bare belly down here. We didn't have any data for bare belly in the Wiltshire because it's kind of relatively fully shedding, and so it's hard to tell. But with this bareness, you can actually still see kind of a hair area as opposed to a woolly area around that bare breech. So we ended up with 91% of those Wiltshires having something of that bare breech area through there, through down to the Romneys, relatively unsurprisingly, having most of the animals with full wool in that area. And it was kind of the same for the breech bareness and the belly. So, one of the things that we did also, because I had the Dags score, and Kathryn will touch on it, but in this particular data set, that Dags score heritability was 0.33. We have all of the genetic and phenotypic correlations that we can talk about, but just in the interest of time, just kind of summarising that these traits, as we kind of heard earlier, aren't the be-all and end-all of getting no Dags or anything, but they are certainly a tool in that toolbox to help get to those no Dags. But also when we think about the works wanting to have very clean animals going in for processing, to not have that belly wool or to not have that breech wool that needs to be cleaned up before they go to the works is a huge help for these type of animals that have these traits. And so kind of in summary, these physical traits, they kind of improve the welfare. We've heard about fly strike, we've heard about those kind of issues. But it's also kind of some of those other traits around the ease of management of these animals. These traits have a very high heritability. Things are okay for the fins and tetzels, even though they've got relatively little variation. But for those Romneys, we really do have to think about how might we go about trying to achieve those shorter tails in those particular breeds. I guess the thing for Robert is that if he ever finds one that has a really nice short tail, he needs to make sure that it's recorded, and that could be the start of a novel breeding program. But we heard earlier about, well, what are the other ways that we can do this? We know, and we've got a student at the moment who's actually working on looking at genomic regions associated with these traits. We know from other species overseas, tail length can often be just 1 or 2 mutations, explaining not all of the variation, but a lot of it. So if we can actually find one of those mutations, should we be using gene editing or genetic modification to very quickly bring it into our breeding populations? So I guess the upshot of it is, I don't know what comment Scobie wants to make on it, but these are traits. We know they're highly heritable. They have significant welfare outcomes, and it's really just get on and start thinking about breeding for them.
Yep, probably more of an observation after spending 2 days at the bottom of a chute, doing tail length, measuring back leg, skin and tail length. But what I found unbelievably massive variation was in weight of tail, and also how much wool grew round the tail. And it's always ironic that we start measuring something and then realise we should be measuring so many more things at the same time. But yeah, even within a flock, massive variation.
Just to clarify things, you mentioned about the bare skin on the tail. How much effect does that have on the actual DAG score?
So in the paper that I've just published, and I just didn't put up in the interest of time, it has a phenotypic, so a real relationship out in the paddock, but also a genetic correlation in terms of the breeding potential. It's low, but it's real. So there is definitely merit in those clean skins actually conferring some advantage. It's not going to explain all the variation in DAGs by any stretch, but it's going to help.
Oh, all right. Thank you. Oh, one more.
I'm going to ask a dumb question now. Where you've got DAGs, have you necessarily got worms?
That's Kathryn's presentation. I'm going to defer.
So Robert sells his male lambs in December store and his surplus female lambs at the same time. So he's got a relatively low population of lambs on the farm for the summer. So does that not make it easier, or easier to find clean pasture? And how does that affect your results?
We've still got plenty of sheep, and I think what you're touching on there is a big part of people that are trying to prevent or overcome drench resistance. Is there are multiple facets to it. The genetics are a big part of it. Your grazing management, you're rotating your species, all those sort of things. They're a big part of it. No one part is going to fix or prevent drench resistance. But even on our farm, we're 25% cattle, 25% deer, 50% sheep. But there are parts of the farm that might be only deer because of the deer fencing, and parts of the farm don't see much sheep or don't see much cattle. So just because you're 50-50 doesn't mean you've actually got it right. You've still got to work those species in together. Just selling your lamb store, you're going to pass the problem on to whoever's buying them, and they won't come back the following year if you've got drench resistance. There's a lot of different facets to it.
And that leads us nicely into Kathryn's presentation.
Ginny might also be able to help answer some of these questions as well. So today I just wanted to talk about some of the health and welfare traits that are available to breeders and therefore commercial farmers as well in New Zealand. In this picture here, we have all the underlying traits, so those that are available to be recorded in industry at the moment. So we've already heard about Dags score, internal parasites, bareness and breach, well, be that breach or belly, tail length, body condition score. The only one that hasn't been talked about today is facial eczema, and we're probably not going to touch on that, but I wanted to briefly talk about the two, so internal parasites and pneumonia. And forgive me, while I was going to talk about parasites first, it makes much more sense given that Ginny's talking to you next for me to talk about that second. So I will flick through our slides, talk about pneumonia first, and then come back to parasites. So chronic non-progressive pneumonia is a subclinical form of pneumonia in sheep. It occurs most commonly in your lambs, so between 3 and 10 months of age. What we've seen is actually in lambs at slaughter, there's between 30 and 40% incidence of some form of pneumonia in their lungs when they go to slaughter, and that increases as we go throughout the season. So we've found that in our research, and it's been published by research out of Massey as well. Pneumonia is a pretty complicated disease. There are, there are multiple infectious agents that can cause it. So that's bacteria, that's viruses, that's mycoplasma as well. And that's just in the causative pathogens. Then we also have the environment and the host genetics as well. So there's these 3 different factors that are coming together and causing disease in animals. The cost is estimated to be, well, back in 2008 was estimated to be $53 million to the New Zealand sheep industry. So that will have gone up with inflation. And that's mainly from reduced growth of animals and then downgrading of carcasses at slaughter because of pleurisy. So back in 2008, AgResearch started the ovine pneumonia project, and that was development of an in-plant scoring system. It's pretty simple because it's on the gut trays, so it has to be quick. You have about 3 seconds to look at the lungs and score them. So 0 is where we have a lung with absolutely no lesions on them. 1 is less than 50% of any lobe is affected, and then 2 is more than 50% of any lobe is affected. And we define it as areas of consolidation. So areas that are hard to touch, a dark red, look more like the colour of your heart as opposed to the fluffy pink lungs. We've now recorded over 16,000 progeny test lambs at slaughter, including the low input ram lambs. Unfortunately, we were planning on doing a second year of recording them last year, but last year was the first year actually that since I've started AgResearch that we haven't been in plant and followed lambs through on the gut trays. Because of COVID, we weren't allowed in. So this year, well, this cohort of lambs that are on the ground, we do plan on following them through again. So most of the flocks that we record from are based around the southern part of the South Island. There's a couple from the north that were part of the Farm IQ program that we followed as well. And so here you can just see over time the incidence of lesions at slaughter. The light green bars are the 1s, so a little bit. Dark green are the 2s, a lot. The average over all of our data set, even though it's quite variable, is around about 30% of lambs. So that fits with what we know from the Massey research. One of the things that I personally find quite interesting is that as commercial farmers, most of you will actually only be getting information back on pleurisy, not necessarily pneumonia. So the average incidence of pleurisy, as recorded by the meat inspectors over these years, was 7%. So 7% pleurisy, 30% pneumonia. I've talked to some farmers in the North Island who are getting 40 or 50% pleurisy on some of their kill sheets. So it might be a bit more of a problem than we think because it's that subclinical form of pneumonia. So our first question, as always, is there variation between animals as geneticists? Our second one is it heritable? So is the sheep's genetics playing a part? What we find is, yes, it is. Depending on which data set I use, and our biggest data set, which also means we have the most environmental variation, the heritability is 7%, so 0.07. If we look at a few of the flocks where we have larger numbers, so bigger contemporary groups, and just look at them, the heritability was 16%. So what that's telling us, this is what we call a lowly heritable trait, but it's still heritable. The host genetics are having an influence on whether or not that animal gets sick. As you guys have already asked, and Suzanne and Tricia have talked about as well, we also look to see if it's correlated with any other traits of interest. And from our initial research, it looks like there might be a positive genetic correlation with FEC. So that's parasites. But before you get too excited, so usually when we talk about genetic correlation, it's the same genes are controlling both traits. In reality, it's probably more likely that animals that have had been able to cope with the parasite challenge better, therefore have more resources and are able to deal with a challenge with pneumonia later on in the season. But regardless, you want sheep that can do both. So you want sheep that are more resistant to disease overall, as well as specific diseases for your region. So we have actually, including the low input animals, we'll hopefully in the next month redo that analysis and see if that holds up, because most of our data is from one flock, our Woodlands research flock for that. So looking at re-estimating those parameters. The other interesting bit that came out of the pneumonia work is that animals with lesions at slaughter had actually grown more quickly from birth to weaning. So the fast-growing lambs on mum then had slowed down post-weaning. They were the ones that were more likely to have lesions at slaughter. And it took me a while to get my head around this, but I guess it potentially makes sense if you think about animals that are growing fast, all of their resources are going into growth, and that their immune system might be lagging behind. So this actually holds up with the work that Kathy Goodwin-Ray did out of Massey as well. So one of the interesting findings. This work is continuing on. We are looking at using ultrasound as a way of looking at lesions in live animals. There are some breeders that are quite keen to become involved in this work, but at the moment, to look at the lungs, they need to be out of the animal, and therefore you can't breed from them. So progeny tests at the moment are our main source of this data, but are looking to see if we can use ultrasound as a way of looking at pneumonia in the live animal. So that's a whistle-stop tour of pneumonia, and then I'll talk about parasites and I can take questions at the end, perhaps. So for parasites, if we think about our toolbox, the analogy that Robert used before leads nicely into this. So in terms of dealing with parasites, in our short-term tools, we have trenches, but they are increasingly failing. You talk to some of the vets, particularly up in the North Island, and there's resistance to triples, there are big issues, and it's looming. In the short to medium term, you do have things like management, which Robert touched on as well. So nil drenching of adult ewes, refugia, integrated species, so mixing deer and cattle and beef, and also feed. And having listened to Ginny recently, I imagine she might mention this again, is that a well-fed animal is much better able to cope with disease challenge. So nutrition plays a big role in this as well. But one of the tools in our toolbox, particularly for long-term, is genetics. So it's not necessarily a short-term fix, but it is a long-term solution because genetics is permanent and cumulative. So if we look over time, this is a breeding index. So index is the breeding values multiplied by the economic weight. So higher is better because it's money. Over time, with 1990 on the far left, this is a genetics trend graph through to 2020. This blue line here is the industry average of all dual purpose flocks for fecal egg count. So while it might be slightly biased, this along with the report that Abacus did showed that overall we are getting worse at resisting parasites in our industry. And this is probably because there is a slight genetic correlation. It's low, but it's there with things like live weight, and I think fleece weight, that will be in a later slide. So if you ignore it, it's going to get worse. The light gold line is all of our current worm-connected flocks. So it bounces around, and that's because, as has already been mentioned today, more breeders are actually starting to measure their flocks. So as they come in, the average gets dragged down. What we do, if we split out the top guys, so these are the worm-fed gold members, these are the ones that have been breeding for over 8 years. They have good average dual-purpose FEC indexes, and they've been testing a certain number of animals per year, is that you can see that for FEC, you can make great genetic progress if you select for it. And that's because it's a moderately heritable trait. The heritability is around about 30%. But we need our animals to be productive, which is often one of the big things that people say. And as we can show here, so this is New Zealand maternal worth, that once again, blue's industry average. The two gold ones are either worm-fed connected or worm-fed gold, and that they are still trending above average for the national flock for maternal worth. So while there might be some negative genetic correlations, they are small. And if you use index selection, so if you're selecting an animal on something like maternal worth plus FEC, you're still able to make progress in both, which is sort of one of the main things I think I wanted to push, because people quite often think that an animal that's disease resistant can't be productive. Another thing to think about as well is that for worm FEC, if you look underneath the hood at the epidemiological model, so what's actually happening, how we estimate the loss from parasites, is that it's actually looking at things from a whole flock or mob level. So you might have one resistant sheep in a flock, but it's not doing very well. And that's because potentially of the challenge to the whole mob. So research, modelling from New Zealand and research from Australia shows that the benefits of using resistant sheep are less drench, faster growth, and more wool. But that only actually works when you graze resistant animals separately. Because there's less eggs on the pasture, it means there's less larval challenge to the animals, and there's less, they're having to fight that parasite burden less. So it works at the whole mob level rather than the individual animal. And so underneath worm FEC, that's what happens in the model for the breeding values. We're looking at what will happen if you're reducing the fecal egg count, reducing the larval challenge for all of your sheep, not just for a subset of them. This is actually data from, I think it was the second cohort of the low input animals, looking at fecal egg count along this way and then live weight gain in this way. Each dot is a sire and the crosses are the variation within his progeny. And this is just showing that you can have sires that have lower fecal egg counts but don't grow well. But what we're really after is these rams here. The rams whose progeny, they have low fecal egg counts, so your pasture contamination's lower, but then their lambs are also growing well as well. And this is under challenge, and as Robert's already mentioned, they get a fairly serious challenge here as well. Correlation between parasites and Dags. So there is the industry-held view that if you breed for resistant sheep, they are going to be more daggy. And I'm talking genetically here, not the animals that have a high parasite challenge will get daggy. I'm talking about the genetics underpinning it. So a number of years ago, Natalie, well, I shouldn't say a number of years ago, it's probably only about 10, Natalie Pickering did a PhD on this, and she actually looked at information. There was at the time 130,000 FEC records, so parasite records, and 45,000 DAG records at 3 and 8 months. And she looked to see what those correlations were. So if you breed for resistant sheep, are you going to get daggy sheep, and vice versa? Her PhD, interestingly, was also looking at using DAG score to reduce fly strike. So what that shows is that there's not really any sort of genetic correlation between DAG score and fecal egg count, so parasite resistance. It's not significant. But even if there was, you can counter it using a selection index, which, like we've already talked about, that's animal breeding. When you're wanting to select for multiple traits, you need an economic index in order to make progress on them all. And that's it for parasites. Sorry, this will stop.
Kathryn.
Sorry, I might have had a summary slide. Sorry.
Yeah, no, go for it.
This is what happens when you do presentations backwards. So there are genetic differences between animals and their ability to resist diseases. And we are starting to look under the hood a wee bit and look to see how those different diseases and the resistance to those different diseases interact as well. So The point being is that breeding is permanent and cumulative. It does result in a reduced cost of treatment, as well as all of those other reliance on chemicals and antibiotics that consumers are looking for as well. And so you can use breeding, or you can ask your breeder to use breeding to lead to improved health and welfare of your livestock. So that is the aim of our research, using genetics to breed healthier and more productive sheep.
Well, I knew I'd get a few questions. So we're going to switch to Ginny quickly and we'll combine the questions. But just while we do that, I'll take one quick question.
Yeah, just one word that hasn't come up at all in the presentation is resilience. And
I thought I could get away without that.
just a couple of comments on that, Kathryn.
Yeah, so at the moment, well, within SIL, the issue with resilience is how you define it. So at the moment, breeders in SIL, or in Improve, I should say, is actually looks at growth under challenge. So as Robert said, you have a control mob that you regularly drench, and then you look to see how other animals who aren't drenched perform, and it's days to first drench, essentially. One of the issues is that that doesn't actually take the fecal egg count into, that isn't recorded on the animals. So we're assuming that reduced performance is because of worm burden, but it's not actually quantified. One of the other issues as well, as Robert well knows, is you're having to bring animals in and weigh them all the time to look at their daily live weight gain to see whether they need a drench or not. Aside from the sheer labour of that, you also run into other animal health risks, for example, something like pneumonia when you're constantly bringing yarding in animals and all the rest. So I think while our ultimate game is resilient animals, we want animals that are able to cope with varying levels of challenge by parasites and other diseases. At the moment, we don't have a great protocol for measuring that. And particularly in sheep, with the way the protocol is that, the number of breeders actually using it is probably decreasing. The other thing, because you're not taking fecal egg count into account, you can get an animal that grows really well under challenge, but has a really high egg output. And that's fine for that animal. But then when you look at the mob animal, all of a sudden your larval challenge gets really high. So in terms of the epidemiology of the parasite infection, that can lead to some complications. But in saying that, there are some examples in industry of rams that have really great resilience. It's just thinking about the impact at the whole flock level. And I think that's something that's increasingly coming up, is we need a better protocol for how to measure resilience, and probably take into account that reducing egg output as well. You can just select on fecal egg count and growth, but I don't know necessarily that that's quite perfect in terms of their phenotype. Well, they're not mutually exclusive. Yeah, so you can select for both, but I think, which we've had discussions before with BLG and with the breeders around what a good resilience protocol might look like. So, yeah.
We might come back to that discussion once we've heard from Ginny, but Hamish, I think you had a question, but we will, if we can do it after Ginny, that would be great. Ginny, I think you're online. We've got your slide deck up, but hopefully you can hear us.
I can hear you.
Oh, cool. Perfect. We can hear you too now. That's great.
Great. Hi, everyone. I'm sitting in the boardroom at Vet Ora in Otahonga today, so I would rather be down in that woolshed even before I took on the Wormwise role. I think this piece of work that's gone on down there is just so important, and I have been following it. So, sorry that I'm not there today. So we'll do our best to do this virtually. Kathryn, I'm the medium term. The short term being drenches, as you allude to, which we certainly see around the country. When you talk to farmers about drench resistance now, it's all triple drench resistance and double combination drench resistance. People have almost forgotten that just single active resistance was a thing. I've seen some data sets from Central Otago and North Canterbury when I was down both of those areas earlier in the month, from vet practices running around about 30 to 35% of farms that they're testing with triple drench resistance. So it is definitely not just a North Island problem. But I want to talk about this stuff in the middle. We often, when we're talking about worms, if you walk into the place where you buy your drench, it's all about what drench should you use and when, and what shouldn't you use, and and then at the other end of the spectrum we've got genetics where we've got animals that need very little drenching, but if you try and leap from one to the other without this management stuff in the middle, I worry that we're going to turn a whole lot of people off our messages. Getting this farm system and feeding stuff right in the middle, whether you're an ethical veterinarian or a provider of advice who's trying to talk to farmers about using less product, or whether you're a low input breeder trying to sell them a ram, if we don't talk about this stuff in the middle, those other solutions that we've got are going to fall flat. So that's what I want to just focus on today. Why is this not going? There we go. Okay, so, in Wormwise workshops, we used to spend a lot of time talking about keeping the superworm outside your farm gate, and, quarantine protocols and all that sort of thing. And yes, they're very important. But, as I've alluded to with some of that data, the superworm is inside the gate on a lot of farms, and it's a question of either heading it off before it actually starts causing production loss, or in some cases actually winding this whole thing back. So people, when we talk about farm systems and worms, I often hear, oh, but every farm's different and there's no rules and you can't give people rules. And I actually think there are some rules, and the further away from them that you go, the more that you break them, the more likely you are to then end up with problems of both parasitism as a disease and a production limiting issue, and also drench resistance. So I call these my rules to live by, and these are them that's already been mentioned. But the role of an undrenched ewe flock in terms of providing refugia on a farm, and also as net removers of parasite larvae for young stock, whether that be young lambs or whether it be young calves even. Super important, but we can't just rip out all the drench inputs if a flock has been heavily dependent on them, because the outcomes won't be good. And I am hearing of some examples of that around the country in the last few years. So we've got to do better with that. And then these lambs, they are your parasite factory, right? Minimising the number of days that they are on permanent pasture on your farm, whether that be by a whole lot of grazing management rotations, swap of stock classes, things like that, or whether it be novel forages. There are a range of solutions for different farms as to how to minimise that, but it does need to be one of the rules to live by. If we're dragging lambs all the way through from weaning to winter and then selling a bunch of them store and pinching a whole lot of feed from the ewes, which I see a lot on farms, that's what you're breaking that rule and you're contaminating the farm for next year. And also then that undrenched ewe flock becomes more difficult, one, because they're underfed, and two, because there's a whole lot more parasite larvae out there on the grass. So, while there may be no rules, I actually think there are, and those are two of them. So the undrenched ewe flock, they need to be undrenched because they don't require any drench, because they're so well fed and so well managed. If we just, as I've said, if we just pull the drench out, it's going to go bad. And when we talk about a highly productive ewe flock, every analysis I've ever seen of the money that a ewe flock makes is determined by this thing. And the determinant of that, scanning percentage is one thing, right? But there aren't that many crossbred flocks in New Zealand now where scanning percentage is really limiting, or has to be limiting. So it comes down to this end of winter management, right? It's that last bit of pregnancy, that last 3 or 4 weeks before lambing, and then the feed on offer. That's what food is. pinch that from Australian. I like that. And then it's that feed on offer, that food, that grass under their feet, whether it be the height or whether it be the rate that it's growing, or both, at lambing. The closer we can get to meeting ewe demands at that time, the less likely they are to need any sort of anthelmintic treatment at lambing. But you can't just wake up, right, on the 15th of July and decide that we're going to get all these things right. This whole thing starts back before tupping. A guy in one of my discussion groups always says that winter starts on the 1st of February. And I think that's so true. So we've got to set this whole thing up prior to tupping. Ewe body condition scores got to be really good prior to tupping, because we know on our winter rotations that they're going to lose some weight. So if they're only condition score 2.5 or even condition score 3 at tupping, if things don't go quite to plan in the winter, you're going to have a whole lot of really light ewes at lambing. And there's so much data to show that, the production, survival and the lamb growth out of those light ewes is so much poorer than ewes that lamb in good condition. So those are some of my targets at the bottom there. I think it's quite normal in bigger and hill country flocks for a lot of ewes to run down to probably more like 2.5 at lambing, even though 3 might be ideal. But let's not let perfect be the enemy of good here. If we could get the vast majority of the ewes at 2.5 instead of a big bunch of them at 2, I'm happy with that. Let's not beat people up with perfection. And then the other thing is the whole farm cover. If your farm cover is 1,200 at lambing, you haven't got many paddocks that are over 1,200, or, half your paddocks are under 1,200. And for good performance, we don't want covers to be ever dropping down below 1,200 to those ewes. And so, that makes it easier to achieve if we're actually managing to set stock onto more like 1,400, because we know typically when we set stock that the covers are going to drop unless your lambing date is quite late. So, setting the whole thing up so that we meet these targets when we're coming through to lambing, I know I'm lucky that working for Wormwise half time and doing my own consultancy the other half of the time, I actually get to see this stuff play out. And so I've got some confidence here in my numbers, because I know that it works when you get it right. What else about these girls? So, if your breeding flock is your main source of income, which it is on most of our hill country farms, then the requirements of these girls come ahead of every other class of stock. And holding that last group of lambs, waiting for the schedule to start rising again in the autumn, or at the other end, not selling a cut because the schedule's too low earlier in the season. Totally accept that selling all lambs at weaning, that can be a financial cost, but just those groups of lambs that could go and should go. I've heard Rob McNabb say those lambs that in your heart of hearts are still going to be on the farm on the 1st of May. You know who they are. Who they are pretty early on. And, they're the ones that are doing all that pasture contamination on the North Island. A lot of them have got quite bad pneumonia and also, so they're growing slower as well. So some magic numbers, feed at lambing. I've already talked about that. And I think more and more picking a lambing date that fits your pasture balance state, i.e. when that demand from your stock is about in balance with what the pasture growth will be doing, is really important, because it used to be really easy in the hill country just to bang nitrogen on prior to lambing and artificially lift that pasture growth. Even though you couldn't see the grass there, it was growing and the ewes did better and it was all good. But, this is getting a much more expensive proposition to do over a whole farm every year now. So I think we do have to be a bit more thoughtful about our lambing date and getting that feeding right to the ewes with more detailed and careful management rather than just flying it on. So, this presentation originally was a presentation to vets. And it was coming to that point where if we just start telling our clients to pull out drenches because, capsules are a known factor for drench resistance, and we shouldn't be drenching ewes at docking. And, there's all these times when we supposedly shouldn't be drenching. But if we just tell people to pull out drenches without talking about this other stuff, without identifying where we see feed that's too short, ewes that are too skinny, what happens? if the management stuff isn't got right and people start to pull out anthelmintic inputs, and this is the same when you start buying genetics, right? If we just think that the genetics are going to do it for us and we don't sort this management stuff out, you know, all of us giving this advice, whatever it be about, it just gives us a bad name. So we have to talk about the elephant in the room. We have to talk about the skinny underfed ewes, and we have to, as an industry, look for opportunities to do better. Have I got time to talk about lambs, or do we need to make up time?
We do need to make up time, but if you can do it quickly, because it is important.
Yeah. Okay, so I won't go through all these slides, but I did talk about lamb grass days, right? And this is really important. The more that we are trying to feed, I'll just skip through all that because finishing systems. Yeah, lambs, here we go. So if we're trying to grow out a bunch of lambs to a predetermined slaughter weight on permanent hill country pasture, and especially once that clover is going in the pasture, if it's getting drier over the summer, you know, that's when our growth rates really crash, right? And we need to work around that. So knowing also that lambs are that main driver of our autumn pasture contamination, we need to think about how we set up breaks in the system, whether it be lamb sales or whether it be our grazing management or forages or whatever, so that we're not just trucking lambs around back on permanent pasture, that same area that we lambed on, which, let's face it, for hill country farms typically is a lot of the farm. So it's really cool if you've got a land resource where you can do summer cropping, autumn cropping, new grass, that sort of thing. But for a lot of our hill country, that is not possible. So thinking about how we can prepare some areas, maybe with cattle, or in your deer block, where lambs can get weaned onto after weaning, so that initially they're not going straight back onto your weaning area. Then maybe doing some cleaning up with ewes. Something I see and hear working really well is on farms that have got a reasonable cattle ratio, is trying to set up fairly long rotations so that lambs are taking a really long time to come back to where they were before. If they're just going round and round and round a little, you know, supposedly better quality area on the farm because it's better lamb feed, you know, they're going to be doing way more contaminating on that area and also breeding up your drench resistant worms. There is no one, this is where there is no one recipe. And I think this is an opportunity for people to sit down with someone who really gets the parasite side of it, and then, you know, figure out together with either yourself and that person, and maybe your agronomist or your whoever else can help brainstorm as to how you might do this and create more clean feed for lambs to grow out more quickly on. I think that's really key. But the other thing about having lambs on clean feed, I won't go there, is just the need to not be drenching as regularly when you're on that feed, because if there's less parasites out on the pasture, there is effectively less refugia. So you need to be careful that you're not just populating that cleaner feed with more drench resistant survivors. But happily what you do find when you start monitoring is that typically, you know, once you've got lambs on this kind of thing, do some fecal counts at 28 days, which would be your normal drench interval. And more often than not, the egg counts are really low and you can go a little bit longer, or you can choose to leave some animals undrenched. Again, this is an area where I think getting specific advice for your farm is really important. I don't like sound bites about this stuff. But yeah, just being cognizant that wherever you are providing clean feed for lambs and for 100 kilo calves, that you do think about reducing some of the drench inputs just to stop that extra selection for resistance. So that was the main point I wanted to make about the lambs and finishing systems. Hope that was quick enough.
Thanks very much, Ginny. That was great. So we're going to have a bit of a combined question time with you and Kathryn now. I think Hamish had a question for Kathryn earlier, so we might start with him.
So I'll start with the question first, and I'll put some context around it. Do we need to make the health traits and the indexes higher, more value? Because it's interesting, when you say worm resistance, it doesn't cost much to drench, etc. But when you get triple drench resistance, it costs you heaps. So it's very cumulative and hits you big time. So what I wanted to say is we have to be very careful, I believe, this is a contentious discussion maybe, of just focusing on indexes. So when we say to farmers, look, just go to the maternal worth index and select all your rams by that, is really misleading in some ways, because when I go through and I select all the top 10% on Improve, which thanks to Dave has done a fantastic job, I get hundreds if not thousands of animals. Then I go through worm fact, Dags score, body condition score, all the health traits, and I put minimum values on, and I get down to 25 animals. So if I add all those health traits in the indexes, Dags might be 50 cents out of a $50 index. Wormfect might be $1 out of a $50 index. So the health traits have very little bearing on the overall index because the production traits are so high. So we have to, I believe we have to educate farmers that we have to look at those individual indexes alongside the main productive index. So that's why I'm saying, do we need to make those health traits higher in their value so they get a little bit more respect?
I think it's probably more, like you said, encouraging people to, and like that's what we say to people when you're choosing rams, and I know that BLG say it as well. It's around, yes, looking at an index like maternal worth, but you can get two animals that have the exact same maternal worth index and they're completely different. But it's good to use as a baseline. So to say that these animals are going to perform well, but then it comes down to what are your goals on your farm as a ram buyer? What traits do you want to focus on? It's already been said today, there's no perfect sheep. So you're going to perhaps get a ram that is really high for parasite resistance, but maybe he is terrible for Dags, or maybe he is terrible for one of those other health traits or growth or something like that. So it's about, I think it's, I understand your point about the economic index, and perhaps that might change as drenches are no longer able to be used as much as they are. I'm not an index expert. I'll that one over to someone who used to work for Abacus. But I think that, like you said, encouraging farmers to actually look at those sub-indexes, like to look at the breeding values, is really important. And you can't make progress on, well, if you try and make progress on too many things, you're just going to make a tiny bit of progress on each of them. So it's probably picking the right ram team as well that you're using on your farm to make progress. Yeah, well, the right breeder to begin with, yes, but then the right ram team too. So
I've got a question from Alan Richardson online. Do we know how much feck variation there is between resistant and susceptible ewes pre-lambing?
I'm going to pass that one to Ginny because I know that she's shown some of this data before. Was that pre-lambing?
Yeah, and Hamish, we could do a little worm-wise video or podcast or something about what you just talked about, because I think most farmers probably wouldn't go to that level of detail, and it's really important. Yeah, so if you go on the Wormwise Facebook feed, there's actually a little thing about exactly what you're talking about, Alan. It's only an example from one farm, which is Romani. I didn't say that on the Facebook feed, obviously, but I put up some pre-lamb fecal egg counts from them. You know, these ewes had egg counts of mostly 0 and a few 50s and a few 150s, and yet, you know, when I look at other pre-lamb fecal egg counts from other clients, you know, they can be very, very different. That said, talking to a farmer in Hawke's Bay this year, had some ewes with a fecal egg count pre-lamb of 800, but they're going on to fantastic feed. The ewes themselves look fine, and he said, I'm not going to drench them because I'm going to back my management, and it went fine. So, you know, again, good management trumps a lot of things, but yeah, that's all I know about pre-lamb fecks and resistant flocks.
Probably, like, we don't tend to, one thing to note is while there is a breeding value for adult feck, that's not actually based off fecal egg counting adult sheep. It's based off the genetic correlation with lamb fecal egg counts. So we don't routinely fecal egg count any of our research animals, adult research animals. We just do them as lambs.
I think Kate Broadbent has asked if she can speak to Hamish's question. So I'm just going to ask Kate to unmute now if she can, and she can speak to that.
There we go. Can you hear me?
Yep, we can hear you.
Great. So I've been a participating breeder in this trial since the onset, and I know you've given lots of thanks and appreciation during the day today. I'm really sorry I wasn't able to be there, but again, a big thank you to Beef and Lamb Genetics and to Robert and his crew for the work that's been done. Just to Hamish's question about, why aren't we weighting these health traits more? I think, and I see it this year, I've seen it the last few years, the market is going to start to demand that. The ewe numbers are going down and the ram breeding community is the same size. And I think unless ram breeders get on board and start to measure some of these things, unfortunately, some of them are going to fall by the wayside. And, it's appalling to me that they don't all measure Dags because it's free and it's simple, but that's a conversation we've already had today. But yes, I think the health traits will increasingly become more on the radar for Beef and Lamb Genetics and SIL and NPROVE and so on, because the market signals are very much indicating that. We sort of question why meat isn't in the New Zealand maternal worth. We've taken wool out because it isn't an economic trait anymore. Meat is an economic trait and not in there yet. But feck, Dags, those sorts of things. I made a suggestion to Beef and Lamb Genetics at the roadshow that we say in 2025, Dags will be included in New Zealand maternal worth. You're going to give the breeders enough time to start recording and get them on board. And I think the most important thing that is going to come from this trial with the results that we've got, these compelling results about Dags and sire influence and and what we can do through genetic selection, is getting that extension out to the commercial farmer and getting them to question their breeders. I don't want all these breeders to fall by the wayside. We need them out there, but we want the ones that are forward thinking and going to follow this route because it is the future. And I sort of refer to it as traits of the future. This ram selling season, I rarely talked to my clients about rams. We talked about feck. We talked about Dags. And that market signal is the strongest signal we've got. So I completely agree with Hamish. I think we need to weight them heavier. But the commercial farmer, I hope, and I really feel will drive that, especially with the results from this trial getting out there so that we can, and fortunately, we've had such great results, and maybe we can use this to leverage more work in the future as we look at efficiencies and we look at different things. So thanks very much, everybody, again. I wish I had some of those good sandwiches because I'm kind of hungry here with my peanut butter.
Thanks, Kate. I think we've got a question at the back.
Sorry, this is going to pertain to the pneumonia section, but knowing that we have a great understanding of the internal parasites that are causing specific diseases in our sheep over here, is there any research in terms of the respiratory pathogens that are causing pneumonia lesions, understanding that like bacterial pathogens are usually a secondary infection, whether it's concurrent disease or a decrease in immune system mechanisms, versus like a viral pathogen who may be a primary infection, just to help maybe with management strategies for our low input commercial farms?
Yeah, so there's been some work done into the causes of of pneumonia in New Zealand. One of the things that is on my to-do list is actually that we want to be taking nasal swabs from our so the flock that we have the most scores on is our flock down in Woodlands, 2638, which was mentioned, which is being selected, by the way, on maternal worth plus meat plus feck plus Dags plus methane. So we know that there's a known incidence of about 30% in those animals, and so planning on taking nasal swabs pre-slaughter to see if we can actually start pulling out some of, essentially looking at the microbiome of the nasal cavity and see if it can be used as a predictor. There's some amazing research done in the States with cattle, because in feedlots, respiratory disease is a big problem, and they've shown there's some interesting work that's been done looking at even down to the genetics of the bugs. So different types of the same bugs are more likely to cause disease than others. So it's definitely an area of interest for us if we can use that, because if we could use nasal swab as a predictor, that would obviously be much simpler if we can get the cost of the test down far enough.
Yeah, with all due respect, Kathryn, the number you put up there, 7% heritability for lung disease.
Yeah.
And then what Hamish says, and if you put that in a breeding index, most of the people in this room are going to be dead before they make substantial progress in breeding for that trait.
Yeah.
Whereas what Ginny was talking about, and Ginny was far too soft because he said 2.5. It's got to be condition score 3 because most of the people in this room that's condition score the sheep are not calibrated properly. So they're going to give them generous. And stop bringing your lambs into the yards, stop drenching them, stop dagging them, and just make some progress on your animal health traits like that.
Yeah, absolutely. Like feed and letting the animals be out in pasture is one of the biggest things you can do. What I think is interesting is that even despite all of those environmental differences, it was a genetic component. And yes, 7% is quite low. But then if you look at that map of where we look at our flocks from versus where pneumonia is actually a problem, which is most of the North Island, that I think to me would be one of the really interesting things is going in and recording lambs there. The problem being, the reason that progeny tests don't tend to be run in the North Island is because you have facial eczema and other diseases that mean that there's underlying disease challenges that are really hard to quantify. So while I agree with your point, and there are management, and as part of Kathy Goodwin-Ray's thesis, she did talk about some of the management solutions for pneumonia. I think that breeding is potentially a tool in the toolbox. Probably a small hammer as opposed to a big hammer like it might be with Parasite, but sometimes small hammers are useful.
We actually had a question come through the other day in a discussion that we were having around body condition score, which is to your point, Scobie, but how do we standardise body condition score with different people measuring, as you say, slightly harsher or slightly more generously in different scenarios?
I think...
Pick me.
Well, that's
Ginny. I have wanted the opportunity for years to edit Beef and Lamb's body condition scoring cheat sheet, and now I work for Beef and Lamb. I've got the opportunity. So that body condition scoring sheet that you can download, that's got the how it feels compared to your fingers and all that stuff. I've been able to be let loose on that, and we've got some really great diagrams coming that one of the designers has really sick of me saying, oh no, it's a little bit rounder than that. And so the next edition, and hopefully it'll be the last ever edition of that body condition scoring sheet, will have very, very detailed how does it feel, what does it actually look like in cross section, because I don't think there's there's not one resource on the internet that I can find that's got a real perfect representation of what it actually kind of looks like. And then the how it feels with your hand as well. So hopefully that tool will become like the gold standard worldwide tool. Yeah, but then I've often questioned that too, right, with data going into SIL is how do we know that people are standardised? And Kathryn did point out to me the other day that it's probably not so much the level, it's as long as the magnitude of the difference between each increment isn't different. But yeah, maybe like the cow system where there's actually a body condition scoring training process that you can go through and become accredited. Maybe we need that for sheep too. I don't know.
So I have also asked this question before of Sharon Newman, who was the guru of all things SIL. And she told me, while that might be differences between people, the important thing is that they're ranking the animals the same. So, and that actually stands with a lot of our traits, is as long as there's consistency in the ranking across animals, that is the most important thing. While it would be good to have everybody giving the same condition score, so a condition score of 2.5 or 2 being the same with everyone, I think that's the important thing. And as like for the breeders and the researchers and people putting data into SIL, we do need to make sure that people are trained properly. But yeah, it applies to things like DIC score and everything as well.
That's all true as long as we're talking about genetics. If we're talking about management targets, different thing. We need to have people need to know what a 3 is.
Yeah.
Have we got any more? Oh, yeah, that's all.
Mine's just a little statement, really, saying that there was a farm discussion group down in our area that ran 100 ewes of single bearing and 100 ewes of twin bearing. Each farmer did this within the group. And the ewes had to have a condition score of 3.5. all right? And it's what we all aim for. And they had to have a certain pasture cover. So we're talking good management here. But the difference was shown up genetically hugely with how fast the lambs grew. The very best of them were over 600 grams a day from birth. Some of them were too heavy to go to the works, singles. But, you know, there's your condition score of 3.5, pasture cover right. Nobody, as it turned out, had the right pasture cover. It actually went down because of the weather. So it's still possible. The other thing, how much is beef and lamb looking at the immune system's really what we're talking about, early developing immune system, so that they can tolerate. So a well-fed sheep can handle parasites. And the sooner that a lamb can get to doing that, the better. So there was the Wallaceville one that went on for ages, and then which followed with Carla. Is it related to, you know, I know there's the philosophy thing of less parasites about in the pastures. One of the things perhaps with that is, and there's nothing wrong with that theory, but the trouble with that is that you also only have a certain type of worm that's there. Perhaps I don't know. These ones were talking about bringing on other undrenched stock from someone else to reduce or faluja their paddocks. Have you heard of them doing that?
I can talk about the health trait stuff because it's something that the reason I'm looking at Tricia is because we have an application in at the moment which is actually covers starting to develop an immune phenotype test. So this is something we've been interested in for a while. There's work done in cattle in the States, for example, that looks at both the acquired and innate immune response in cattle and I think in pigs, and there's been work in Australia as well in sheep and merinos that looks at the development of the immune system and then how that links with all our other traits of interest. So it's something like I'm personally very interested in, and hopefully this time next year we'll be telling you that we've managed to start doing some traits on some animals, but it's work that we, myself and Axel Heiser, who's our AgResearch is now chief scientist and he's an immunologist, are looking at developing for sheep. Issue being it's probably not going to be very cheap, particularly to begin with, but like most research, like if we can start measuring 1,000 animals from 100 size, we can start looking to see is there variation, is it genetic, and how it links in with all these other traits. Because yeah, it's something that is incredibly important and quite interesting. And if we could have one immune phenotype that was quite predictive of how animal responded to multiple diseases, because with parasites you have different species of parasite. They are a parasite with pneumonia. It can be virus, it can be bacteria. It's like different components of the immune system, but yeah, that's the ultimate goal. Maybe by the time
to the management stuff there, you know, talking about low contamination pasture and maybe lambs not building up immunity because they're not taking in enough worms. There is published work showing that lambs actually develop a faster, stronger and better immune response from a trickle infection rather than the kind of overwhelming load that they get off contaminated pasture. So they don't need large amounts of larvae to stimulate that immune response and get it going. The other thing that Dave Lethwick and his group have shown too is lambs can ingest, say, cattle couperia, and the challenge from that will stimulate the lamb's own immune response to worms generally, while the couperia aren't really establishing to any great effect. So, you know, that's another benefit of cross-species grazing, is that the opposite worms are still helping develop the immune response, yet not getting up to really big populations to actually make the animals sick.
And yeah, research in New Zealand and Australia has shown as well that if you're breeding for sheep resistant to parasites and like with one species mix of parasites, it tends to correlate quite well if it's a different species mix. There doesn't tend to be, for example, barber's pole or homunculus down this part of the country as much as in the North Island, but yeah, the breeding values still work quite well.
Cool. In the interest of time, we are running a bit behind, but we are now going to head down to the yards to your left. We're going to head just down those steps there. Thank you, Ginny. hopefully you'll be able to stick around for a little bit to keep this discussion going, as I'm sure there'll be more when we get down there. But if we can all just head down the steps into the first yard there, we'll start talking about how we can apply some of this stuff. Okay, so Sharon McIntyre is going to share some insights with us. Sorry about the noise. These are obviously the 22 born cohort of lambs and their mums, which are a mixture of mixed age ewes and progeny test bred ewes.
Okay, so I'm Sharon McIntyre. I did a lot of the number crunching for this, and I found it a really fascinating data set. So the animals that you're looking at there, tails range from 8 centimetres to 29 centimetres, and the average was around 21, 22. So quite a lot around that average, a few really long ones, a few really short ones. This graph here, if you want to swing it round, that's the tail skin. And so we had less 4 centimetres through to 14 centimetres. And you can see them measuring it. David Scobie, are you still here? No. So David did a lot of this work, and one of the things that he's come up with in recent times is about tail molting. So we had the bear breach, and you remember, David? Yeah. Do you want to talk about tail molting? So, you know, in those photos we had before, they had the bare area under the tail, but some animals are shedding the wool right up the tail and across the top of the tail, and this is a separate trait. And that's David. Do you want to
find any? Are there any in there? Pictures. Yeah.
And we haven't got any photos of them.
We never set out looking for molting the wool from the tail. We were just looking for bare bums. But I think some of the sheep genotypes that we picked up, particularly the East Frisian and maybe some of the other European breeds, brought with them that bare tail. So we're not talking about those are from underneath the bum. We're talking about on top. So you should be able to see it just at the top of where the ewes got dags there. There's actually a ewe over there right up against the fence. It could be just a short handpiece blow, but that one looks like it might have shed a bit of wool. And this is the perfect time of year to see it. So go home to your flock, have that unusual behavior and try to pluck the wool out of their bum. So right on their tail, on top of their tail, just try to pluck the wool out. And you will find some of them shedding that wool from their tail. It's inherited completely differently to body shedding like the Wiltshires do, because we've seen sheep that have got their body wool shed, but the tail wool's still hanging on because it shed earlier and started to regrow. So it's a really interesting trait. We don't know a heck of a lot about it. We haven't really calculated heritability estimates for it because it seems to be operating from very few genes.
So one of the things where the beef and lamb team have been doing over the last couple of years is setting up a visual score guide, and it's got a whole lot of traits in, and every time we think we're just about there, they come up with a new one like tail molting, and then you had to have pictures of that. And we've got a whole lot of leg and feet rotation and foot faults and things like that as well, and that visual score guide, but it's still draft, but it shouldn't be far away. So here's an example of the pictures we've got for Dags score, and the bottom graph is the Dags. Yeah, so the Dags scores. This is all the sires were very similar just after weaning, and then you can see we get a bit of spread in the ewe lambs and the ram lambs. They all very similar, and then we went to Dag 8. One stayed very low, and one went quite high. But a lot of them were very similar. But even within each sire, there normally are a few that are free of dags. So, you know, even if you're a very daggy flock, there's normally some variation you can exploit. So that's the pictures you saw earlier. So yep, these are the different sire lines. And one of the sire lines that went quite bad for dags actually had very short tails. So, you know, the comment that someone made earlier that they can have short tails and still have dags is very true. Right, what other ones we got? We've got tail skins, dag scores. this is more of a free flow. Do fecal egg counts. So there's fecal egg counts on the ewe lambs. They had 2. So they were all very similar, probably averaging just under 1,000 here. And then the sires divert. And the highest one averaged 6,000 in March. And the other one was at 3,000. So, quite a lot of variation. And these are based on progeny group. So one of them is contaminating pasture a lot more than others. So here is the ram lambs. They only had one FEC test, and they averaged just under 3,000 at that time. Many of the sire lines were very similar. A couple of were quite a lot higher. So we did try, when we accepted sires into the system, that they were required to either be doing FEC or had a history of FEC, because they did get quite a challenge. So when an animal's parasitized, it leaks proteins into its guts, and it has a protein loss. So Robert's system of putting them onto clover, you get a very high protein diet, and that overcomes some of the impacts of the parasitism, and they have quite a boost. So that's a very effective management tool. Also, the clover goes through the rumen very fast, so you get a lot more of that protein turning up in the gut. So meat's very interesting in that the male lambs go to slaughter, and we get bioscan data. So this here is the bioscan carcass weight from 10 to 26, and up here we have the GR. So you can see that as animals get heavier, they get fatter, but the multicolored dots are the progeny of each sire, and you can see there's not one sire that's all at the top. There's one sire that's a bit at the bottom, but generally every sire had quite a range of progeny merit. But meat is the trait where there's a lot going on. We've got birth rank, rearing rank, we've got age of dam. I find that raw meat data can be very misleading. It's much better to work off the breeding values. So in this trial, we take the data that's collected here and we analyze it just using the data here. So everyone's on a living playing field. Everyone's only judged by their progeny performance. And so when you do that, you get the average is 0, which is this line here. And then to be above the line is positive for meat, and to be below the line is negative. So within that group of sires. So you can see there's a few that are just about average. There are a few that are better, and there's about 5 or 6 that are below average for meat after we correct for age of dam, birth date, and all those kinds of factors. So it's a much better estimate of merit. Okay, estrus. I enjoyed this one. So here's our colourful hoggets. Here's our live weight. So it goes from 30 to 40. And here's our percentage that showed marks. So from 0 to 100%. So if you've got a good eye, there's a slight upward. So as you get heavier, there's an increased chance of showing estrus. But there was also a sire whose daughters were averaging close to 30 kilos, who had over 90% showing estrus. And then we also had some 35 kilo ewes who only had 20% estrus. That happens to be a Corriedale. So a Corriedale is not normally expected to do hogget lambing and is probably not selecting for it. But in this middle range of 34 to 36, if we take out the Corriedale, we've got everything from about 35% to 100% showing estrus. So I think the key message for farmers here is if you do hogget lambing, you're best to go to a breeder that is hogget lambing and selecting on it so that you get the results you want, because it's obviously highly variable. Cool. My last point is we have all these multiple traits, and it's a bit like a pentathlon. You're expecting one animal to be really good at 5 events, and that's seldom the case. There's always one that's a strength for you and one that's your weakness. So these are all the sires down here. The red means you were below average for the trait. So we've got growth, meat, Dags, and FEC. and green means you were above average, and the further your line is, the better. We've only got one animal that's green for all 4 traits. We've got some other animals that are green for most of them, but they're pretty ordinary on that. Some of the animals that are best at growth and meat weren't so good on FEC. So it's hard to think that an animal's going to be very good at all those traits. So it's a matter of figuring out what's most important to you, getting the animals with the right mix. And if you get good at these skills, you can put your own weighting on what you want to put emphasis on, so you can choose the rams that suit you. And improve is a very valuable tool, and you can set limits. You can have an upper limit and a bottom limit. For dryland Canterbury people, sometimes they don't want high reproduction because they can't finish large numbers of multiple rams. But for others, then, you know, if they're facing parasite resistance, then they might want to put a lot more emphasis on DPF, which is your worm feck resistance. So if you spend a little bit of time getting to understand these things, you can use genetics to tailor make your choices. You're going to buy rams anyway, so you buy one that really suits you, or do you just buy an average one? Sometimes you hear, you know, if your ram breeder is not recording the things that are important to you, you should change ram breeder. The other option is you should encourage your ram breeder to breed what's important to you, because sometimes they are sheep that really suit you and suit your situation. Dags, I think, is a bit of a no-brainer because there's no cost and very little time involved, but FEC is no fun. Robert could attest to that. You actually have to get a sample from every animal, and you have to pay the measurement cost. But if clients came to a ram breeder and said, you know, with what we're seeing in parasite resistance, we think this is important. Would you consider, you know, starting to record this? At least it gives the breeder the opportunity to have that conversation and think about doing it, and be confident that maybe if he does it, that there will be a demand for those animals. So that's my final comment. But any general questions about the stock? There's a lot of people that can answer them, but
Sort of an open forum from here on in, and it might be easier to do it inside where it's a bit quieter. But yeah, anyone's got any questions?
Yeah, just before we go into questions, just for the guys here rather than online, just a little bit about the sheep, so you know what's what. So the girls with some multiple tags, they're my original commercial ewes, the older ewes. The girls with just a single small red EID, they're the 4-tooth, so they're the first cohort born in the trial in 2019, and then the small EID blue tag are the 2-tooths, so the second cohort born in 2020. And so these lambs, some of them are out of my commercial ewes, and some of them are a second cross progeny by sort of outside size over progeny trial ewe lambs. And then over there, we've got the last year's ewes born, the 2021 born third cohort. And as we've spoken about the tails, I mean, there are some fairly traditional sort of Romney type tails here, and there are some really much shorter, skinnier tails. The boys have got the tails still on, the girls don't. Just so you're wondering why some do. Someone asked about Carla. What?
Yeah, just wondering why you didn't use Carla as well, just to add to your workload. But why don't we do Carla, or why do we do FEC, or both? Which one? Does anyone know that?
Kathryn's probably best to answer that one, but FEC has a much higher heritability. So if something has a higher heritability, you can, and I think the FEC heritability is almost twice Carla, so that potentially means you can go twice as fast. Carla is more Well, Beck's around that 25 to 30%, and I think the Kala's around that 13% irritability. And it's kind of a more generalized measure, and it can vary. So animals, if they don't have exposure, it can fall and then rise again when they do have exposure. Kala's actually appears to be very effective in deer, but maybe not quite as effective in sheep. But wormveck doesn't work so well in deer, but wormveck works very well in sheep. So it's probably a little bit horses for courses.
Yeah, we did discuss it at a committee level. And yeah, it was only discussed in the year 2, so it already started the program. We had a fair bit on. Yeah, well, I mean, there's pros and cons, because I mean it's cheaper than FEC. You don't have to put them under so much pressure, because they've just got to be exposed to the worms they don't have to be picking them up and build up the challenge over several weeks. But as Sharon said, it's a lot less heritable.
A sample out of the front end's a lot pleasanter than out of the back end.
Mind you, the last time I took a Kala sample, I did end up in hospital because
did you?
I got bitten.
You went too far, obviously.
I got bitten on the finger taking the Kala sample, and 3 days later I went down with blood poisoning.
Oh wow.
Really, just to follow up Hamish's, we've made significant progress using the Kala over 8 or 9 years within an elite flock, and that's been backed up alongside with fecal egg counts. But yeah, it probably a little bit slow to start with, but then once we had the opportunity to cull, there's significant progress in reducing the drench intervals of young stock.
Yeah. It's
Kala. So I'm not sure what the question is, but yes, Kala is a trait that you can record in SIL. It's a swab, so people prefer it to doing fecal egg count. In terms of worm feck, there's a Kala breeding value available now. With worm feck, the reason it hasn't been integrated in is because worm feck, like I mentioned before, is based on reducing the eggs on pasture. The best genetic correlation between Kala and feck is with FEC2, which is autumn feck. And my understanding is that with Kala, it's around about that March is about the time where you get the highest heritability as well. So usually with fecal egg count, you can get, you can do your fecal egg counts on lambs before that. So the reason that it hasn't been integrated into the worm feck breeding value is that you'll make faster genetic progress on fecal egg count if you use fecal egg count itself. But in theory, there is a genetic correlation, so it could be used as a predictor trait. The only other potential issue with sheep is if you're using your rams for breeding, your ram hoggets, is that if you're having to wait until March to do your phenotyping on the animals, that's like a fairly quick turnaround time for selection decisions. So, but in the likes of deer, for example, Kala's great. It seems to work better than fecal egg counts for predicting parasite burden. So it's essentially a measure of the animal's immune response to an antigen that's on the worm, and that's regardless of worm species. So
good luck getting a fecal sample from a heap of deer too.
Exactly.
But now I'd like to invite Dan Brier up to wrap up today, our General Manager for Farming Excellence and Genetics.
Cool, thank you, Sarah. And so for me, I'm really pleased to be able to come here and be a part of the end of this project, which has been a real success for us. Some of the questions we've had today, which ask the question, why aren't we doing this more, or why didn't we do this earlier, are great, right? Because that means that people are getting real value out of the work we're doing, and we're adding to people's businesses. So thanks very much for coming along. Thank you to everyone who's taken a part in the project over the life of it. Obviously, and firstly, Robert and his team here, all of you who are farmers will know that just doing a little project is hard work, and there's many days where you wish you hadn't put your hand up. Doing a big project like this is more than hard work. It's massive. So really appreciate the Orari Gorge team and Robert and all of the hard works and early mornings and pieces that have gone into that from us. So thank you very much for that, Robert. Yeah, thank you. Cool, thanks, Robert. Also the committee. So as Robert made the comment during his speech earlier this morning, that this is, it takes a village to raise a child, and this progeny test has certainly taken a village to pull together. So Kate Broadbent, who joined us online, Robert, Alan Richardson, Dave Reed, who was involved early on, and of course Daniel Wheeler as well. So really appreciate the effort that those farmers have put in helping drive and direct this project for us. The AgResearch team, many of whom we've seen today, Tricia, Kathryn, Suzanne, and Sally Ann Newman, who have helped provide the science and the real knowledge that's helped us be valuable, and also been able to extract the insights. A lot of the stuff we've seen today that they've been able to take from these data sets and pull out, that will help us now and then further into the future as well. MPI, who chips some money in, so I appreciate their input as always. And the breeders. This thing doesn't happen without people submitting their rams. And again, Robert commented on the cost and the effort that you need to go to do that. So I really do appreciate those people who've put their rams into this and let us move this project along. From Beef and Lamb, there's always a big team behind these things. Sarah and Jason have both put in a huge amount of time, but particularly Sarah. And supported by Craig down here, Craig Foote as well, coming down to collect samples, but also behind the scenes too, right? So Cara, Becky, David, Mark with the methane stuff. So a big team effort. Sharon, of course, who we've just heard speak as well. I also want to point out one of our previous staff members, Annie O'Connell, who had a big amount to do with this in setting up. I know she lost a bit of sleep getting this project going early on, so I appreciate Annie and all of the effort she's done to us. So thank you very much for coming. Thanks for your input and your attention and your questions, and have a safe trip home.